and she wanted to know if you had done any evaluation. Does this have any impact?
You mean the collecting surface? How do you...
La perméabilisation de la surface.
The permeability or the infiltration rate of the collecting surface?
Yes, go ahead.
Yeah, well, we can use the, for example, the roof area. It can be the tiles or sometimes the mantle surface of the roof. For other materials, of course, here I didn't mention, because different materials of the area of the surface and also the slopes of the surface or other factors affecting the infiltration rate, or in other words, which linked to the rainfall runoff factor, which is similar with what we learned from the hydrology.
I understand, but I want to know if you evaluate the impact of the l'impact sur la recharge des nappes.
Yes. Groundwater table?
Groundwater?
Table, I mean the underground water. It's recharged. Does it have any impact on this or not?
Groundwater recharge?
Yes. Yes.
Yes. Well, it depends. As shown in my slides, in a very dry area, it's difficult to say any water to recharge into the aquifer. But in the cases I mentioned in my presentation in Southwest China, yes, there are a lot of underground water, even some flows underground. But as I mentioned already, that special geographic condition with cost developed areas is really difficult to maintain or have the groundwater available for the individual households. They living in a scattered mode in the mountain areas. Is your question?
We go to another question.
Thank you, Doctor, for the presentation. I want to find out in the slides you show us in China, in between the high mountains, you dig wells to collect water during the rainy season and use them for irrigation activities. What is the capacity of those wells in terms of water storage? And what mechanism do you use in lifting the water from the wells to the farm? Do you use, is it manual or mechanical?
What are mechanics used for irrigation?
I said there is a farm on one of the slides that you said you collect water during the rainy season. You collect water during the rainy season in wells spread within the farm, and you use the water for irrigation farming.
Yeah.
So what's the capacity of those wells? And what mechanism are you using to lift those water, the water from the wells to the farm?
Okay. Yes, in the slides we show many water tanks in the field, in the farm, on the farm. Well, the volume capacity can be 30, 50, even 100 cubic meters each. Well, when used for irrigation, it depends. If the water tanks are located in a higher place compared with the field to be irrigated, it can be flow gravity, by gravity. I mean, otherwise they can use small pumps to pump water out for to irrigate the field nearby. Is that your question?
No. In one of your slides in China, between the high mountains, where you have a farm with wells spread around the farms, you said you collect water in those wells during rainy season. No, not this one.
Yeah, I understand. Okay, I see. I'll show you. Let me find out the. For irrigation. Yeah. Is this one?
No. This one.
Okay.
No, the previous one before this one.
This one?
Yes.
But the tanks.
Yes, the capacity of those wells and the mechanism you use in lifting the water from the wells to the farm.
Okay. Let me say. Let me clear. I call these tanks. You call these wells, right?
Yes.
Okay. Let's say these tanks. I'm sorry. This is not wells. If wells is connected with the aquifer, you can take water from the underground water resources. But this is only tanks or tanks only. They collect the rainwater during the rainy season and stored in the tanks. And they use for irrigation during the dry season. They are not the wells. Am I clear?
Yes, and what is the capacity of the tanks? Yes. We want to know the capacity of those tanks and the mechanism they use in lifting the water.
The mechanism they use?
In lifting the water from the tanks and the capacity.
Ding? Can you hear me? Can you hear me? Hello? Ding? علاش ما كيسمعناش؟ Hello, Ding, is it a connection problem from your side or our side? We can't hear you. If you hear me, the question is, what is the capacity of these underground reservoirs to collect water, and how do you proceed to take the water out of these reservoirs? واش لا كونيكسيون عنده هو اللي ما مزيانش؟ ما بقاش كيبان كاع.
Hello, can you hear us? Please, he's saying, please wait a minute. He's fixing the thing. He's asking for 1 minute to fix the thing. He's fetching the answer for that question, tricky question. What the capacity of the reservoirs and devices used.
He's back. Dr. KUNLUN?
Yes, I can hear you.
Oh, we can hear you now. The question from a participant was about this underground reservoir you showed on your slide. What is their capacity and how do you proceed to take the water out of it? What's the capacity approximately?
Normally is popular, which with volume capacity of 30 cubic meters to a maximum 50 cubic meters. This is for underground water tanks.
Okay.
And then how to take in water from the underground tanks, it can be used very, very traditionally, use the water bucket, right?
Use what? Water bucket. Water bucket.
Water bucket.
Traditional.
Yeah, but now more and more household in rural, because the power line connected, and the micro, very small submerged pumps, okay. Right? Are used for pumping, which is very small. Could be less than 5 kilo or something like that. The whole size. You just put into the water and connect with the power. Whenever you need water, you just switch on the, you can pump it.
Okay, thank you. Okay, next question. Miss from Djibouti, you have a question.
Thank you, Dr. KUNLUN.
Okay.
Me as a Djiboutian, I'm very interested about this topic and rainwater harvesting system, not for irrigation, but for drinking water. So yes. In Djibouti, we faced many difficulties. You talk about collecting area, and after you collect the water, you put it in the storage tank. And my question is there a pre-filtration system between the collecting area and the storage system, storage and the tank? Because we are facing a problem of the sedimentation in those tanks. Are you facing the same problem in your countries? And what is the solution you have? Thank you.
Thank you. Very good question and a very challenging problem. Yes, we also face the same problem for the water quality when talking about for drinking water supply, even in the remote rural area. Yes, during the last decades, personally, I was involved in several projects which dealing with small scale like this, how to improve the water quality. Because we have enforced the water quality standard for drinking water, no matter for the urban or rural. Yes, this is not only, as you mentioned, not only the problem of water quality, not only the sedimentation within the tanks, but sometimes also the pollutants within the water, from the collecting area. Some are even very harmful or even hazard. This is need the people to keep a close eye on these aspects. Actually, I have a very short presentation particularly for the water quality, but I don't think this can be covered by my presentation here today. In short, I would say, as I mentioned already, filtration, sedimentation tank is a very pre-treatment for water quality improvement. Afterwards, disinfection is necessary. Normally, it's necessary, but in some areas, in a very clean mountain with good ground cover area, it may not be a problem. As I okay.
Excuse me, we can't hear you, doctor.
Hear me? Hello?
Now we hear you. Thank you.
You hear me? Okay. Yes. In short, this is a very difficult problem to solve in terms of the water quality for drinking water. But I said slow sand filtration could be one possible best way to improve the water quality in the rural area with the rainwater harvesting system. That's I can say. Some other, nano filtration or even RO technology. Yes, technology are there, many. But the problem is, can this technology or high-tech are used in the poor, remote, small household in the areas, in the mountain areas? That's the problem. The problem is not the technology availability. Technology are there. So I would recommend slow sand filtration, disinfection with ultraviolet or some safe chemical disinfection are the choices there we can use for the rural area or individual households. Thank you.
Thank you, Dr. Dink, for your presentation. I just want to know, since in some African countries there is a big disparity in time in the over rainfall. So there is a concept held in China that is called the sponge city. Could you tell us about this concept and especially the cost of this concept so we can use it here in some African cities? Thank you.
No, I'm sorry, I'm not exactly following with you.
I was asking you about a concept used in China, which is called sponge cities. Could you tell us about this concept and the cost so we could use it in some African countries? Thank you.
Yeah, thank you. That's also, again, a good question. Even in the urban areas, we also, the government or the engineers launched a campaign to use the rainwater, even in the urban areas, not only to use water resources wisely, but also to reduce, hopefully, the flooding during the rainy season. I think China in these aspects are also needed to learn from other countries. We do have some examples or sample cities or towns use this system. But I'm not very clear with this area because I'm working in most cases in the rural area for the households.
Thank you, Doctor. I would like for you, if possible, to give us some more information on how the Chinese government goes about the rainwater harvesting, because I think if you work too much on it upstream, you might have some difficulties downstream, especially if you have dams in the downstream area, and you lose some of the water and maybe cause even more problems. Is the use of rainwater harvesting very intensive in some areas, and has it caused any problems of the sort? And does the Chinese government allow every person to fund its own project, or are there subsidies? And some places where maybe the Chinese government
I think thank you for your I think your question is at my presentation, very beginning of my presentation. What here I'm talking the rainwater harvesting is in the second circumstances, which means in a narrow sense. It doesn't include in the big reservoirs or dams or pumping water from the rivers. Well, in a small scale rainwater harvesting, this is in a narrow sense. We can imagine how much water or rainwater we can collect it from a so big area, which is minor, which is nothing. We're talking for the individual household or with pieces of land or to irrigate pieces of land. Well, I think in my presentation, this is not a problem, but your question is another thing. For example, we construct a big reservoir, can catch thousands of square area, which is the collecting area. But here in my presentation, we are talking in the small scale, even micro scale of rainwater harvesting system. I don't think the government or any government needed to regulate individual household to collect, use, for example, 10 or 20 square surface to collecting some water and stored for their use. This is not really necessary. That's my opinion. Thank you.
Thank you, Dr. Deng. This is Mohamed WAHBA. I think we miss you too much during this important event, and in this regard, I would like to give you a big thanks. Really, the Chinese National Committee is one of the main supporters for this event from day one. And as you know all, China is going to host the next World Irrigation Forum in 2023. And we hope all to have the opportunity to attend. And in China, there are great development and many advances technology in all other different fields. So it will be a good opportunity to learn and to see this kind of technology. Dr. Deng,
thank you.
Also, we are looking forward to your great support for the young professional and mainly for the African. And sure, we will cooperate in this important aspect. As I will go back to the previous question about sponge cities. China has a great initiative for flood control in urban area. And in fact, this kind of project, it could be for flood control and for rainwater harvesting in urban areas.
Yeah.
Thank you, Dr. Deng.
Thank you, Dr. WAHBA. Thank you very much.
Any comments? Any question?
Thank you, Doctor. I'm Fatma Masoudi, Chief Engineer in the Ministry of Agriculture, Tunisia. Given the importance of this rainwater harvesting, I want to know if there are private projects or at the expense of the state, and what the government do to sensibilize to do this rainwater harvesting. Thank you.
Maybe I'm clearly following with your question. Is any support or subsidy from the government to the users, to the farmers? Right? Hello.
Yes. Do you want the question to be repeated?
Please. Thank you.
So the participants want to know whether these are private projects or government projects, and what does the government to raise awareness about this issue.
Okay. Yes. This individual, or let's say small rainwater harvesting system, including the tanks or the concrete surface for collecting area. Well, it's not a company. They are implemented by the individual household or farmers, if you like. And the government encourage, and they did give some subsidies to support them for the construction of the tanks, for example. Yeah, and also the government how to raise the issue. For example, to use a good water quality for drinking water. This is emphasized and promoted very much during the last decades by the government. Are you happy with the answer? Hello?
Yeah, thank you, Ding.
Thank you.
Any other question or comments? Okay, I guess we are satisfied. I think the participants will have the copy of your presentation. I'm sure they can read it and use it in their professional experience and work. Without delay, I must thank you on behalf of all the participants and the Moroccan National Committee of ICID, because this contribution, as you know, to this capacity building activity, we are proud of it because it's a side event of this 5th Regional Conference, which is organized by the Moroccan National Committee of ICID, and which was raised to be under the high patronage of His King Majesty, of His Majesty King Mohamed VI, may God glorify him. So we are thankful, we are really proud and delighted that this group of young professionals they came to Morocco and they were even in good hands, including from our colleagues from China. Not only you sponsored the training for some participants, but even more, you contributed to this. You had a value-added contribution. Thank you, Ding, and have a nice evening. If you want to say something, you have the floor.
Thank you, Dr. Hossein Bartali, my friend. Thank you very much. Thank you all the participants, and thank you for your questions, and which is very, very important. Make me also to think more in the future, in my work in the future. And I do think the training program now is organizing there are very important for ICID, for irrigation drainage in the future. And I do hope everyone there have a nice day in Morocco. Lastly, I would like to thank Dr. Bartali and also all the staff who contributed to the events organized so well. Thank you very much. Thank you.
When you come back, yeah, I will ask you. I don't know. Do we have like a file, Word file with all your names or not yet? No. But in that case, okay. You have it. Okay, because I need your names to put it on the certificate. Please, so that you make sure the name is written well. Yeah. So if you can collect a word, a file with your names, it will be faster because in the afternoon we have the session of certificate. Okay, so we go for a cafe break.
كاينه في شي بالطوني ديالهم فيها لي زيميل والسميه
مزيان.
Hello, Ding. How are you?
How are you? Hi, Marco. Fine, thank you.
Nice presentation. Very nice. Very interesting.
Thank you. Thank you. It's only some practice in the field. You see. By the way, you are in Italy now.
Yes, I'm in Italy. Yes.
Oh, I see. So you are attending online.
Yes. I was not able because I was not able to go personally because in this time of the year I have some commitments here at my office with the ministry, so I was not able to organize myself. But next time I will surely be attending physically, hopefully in Australia. Maybe we can meet again there.
Yeah, hopefully. And
yes.
Yes. Well, next time it could be, or it can be in Morocco again.
Oh yes, could be. Yes, could be. I think in March. When is it going to be? In March?
In March or April?
Yes, March or April. Yes.
March or April. Yeah.
Are you going to be in the World Water Forum in Dakar, in Senegal, in March.
Yeah, that's as you see, we have 4 months or 3 months away. Still not sure.
Mm-hmm.
It depends on the situation.
Yes.
In China or everywhere in the world, how well controlled the
yes,
pandemic. And
the situation, yes.
Yeah. So what is the situation there in Italy? Is
well, we have in Italy we have almost 90% of the population that has been vaccinated, so we are in good condition. But still, I mean, we are facing an appraisal of contagion, not as strong, not as intense as in Germany, Austria, and other European countries. But still, there is a kind of surge of appraisal of contagion. So we hope that we can make it through next year. But I mean, the situation is not very bad as of now. But we have to looking to see what happens with the new year in the winter time.
Yeah.
How's the situation in China?
Well, I'm sure China adopted a policy of zero infection, so that's very strict. This week, maybe a few, 4 or 5 each day.
Very few.
Or infection cases. But you see, the Winter Olympic is coming 1 month or 2 months later. So the restrictions there is still we cannot traveling abroad, of course.
But you can move inside the country. You have freedom to go. I mean, you can go in other parts of the country, or I mean, is this restriction only applying to going abroad or coming people from abroad? Or I mean, you can move inside the country.
Yes, basically yes, we can. But in some specific areas where a lot of small surge or a lot of number of infections, that will be controlled a little bit.
Are these areas?
Well, it keeps changing. In the last month or
it's too early. Maybe next year it would be better to see what happens first.
Yes, but yeah, I agree, and I really hope so.
Thank you.
Yeah,
let's see what happens next year.
Yeah, because if there were no such pandemic, we might probably organize some activities already.
Hello?
Hello, can you hear me?
Yes, perfect. Thank you so much for waiting and for collaborating with us. You hear me?
Yes, I can hear you very good. Thank you. Perfectly.
Excellent. So I'm very pleased to introduce Dr. Marco Arcieri from Italy. He's Vice President of the International Commission of Irrigation and Drainage, and he's also now the chair of the Permanent Committee of Financial Committee of ICID, General Secretary of the Italian Committee of Irrigation and Drainage, and with the great large experience in water resource management and international cooperation. He has done a lot of work in African countries. So we are happy that Dr. Marco Arcieri has made himself available to share with us his experience, and we left him as the last speaker, but last but not least, because when you will hear him, I'm sure you will be able to collect and rearrange the thoughts you have been told during the previous presentations. So we called his presentation like a synthesis of systems of reducing the impact of climate change on agriculture. So correct me, Marco, and thank you. You have the floor.
Thank you very much, Vice President Hussein. It is my pleasure, and it is an honor for me to give my contribution to this very important training program for young professionals from Africa. I'm very delighted to be here. Unfortunately, I could not make it to be physically with you, but hopefully next time, I'm sure I will be able to organize my things and arrange my agenda in order to be physically with you. I always remember with great pleasure hospitality and the warmth of being hosted by you in Morocco last year when it was in 2019. I was there. I miss, of course, being to Marrakesh, the gem of the Africa, but unfortunately, some commitments did not allow me to be physically with you. But I'm very keen, I'm very happy to give my contribution to this training program for this young professional. Today, of course, my greetings to all of you, to Dr. WAHBA, to President Ragab, to all of you. I am missing you just as well, and I'm looking forward to be with you again at the soonest. Today, I will talk. Actually, I want to tell you, this is, I will present some of the results of a research that I have been conducting in the past 2 years. I think this is a very interesting methodology that I wanted to share. This is the first time I am presenting this data, which are going to be published in an international paper. Most likely it's going to be on our Journal of Irrigation and Drainage, because I think this methodology has very many aspects, practical aspects that can be interesting for a safe water resources management. We are dealing here with drought prediction based on observations of El Nino and La Nina. Someone might ask himself, how come a phenomenon, a physical, natural phenomenon such as La Nina or El Nino happening thousands of kilometers away in the ocean, in the Pacific Ocean, can affect climate in this part of the world, in the Mediterranean, in Africa, and so on. I will show with this presentation the results, the physical results, how ENSO, El Nino Southern Oscillation, can affect rainfall pattern in this part of the world. So, without any further loss of time, I will go through. I will try to share now my presentation. Hope you can see it. Can you see? Can you hear me?
Yes, we can hear you, Marco.
Okay.
We see part of the slides, so go ahead.
Can you see the slide?
Yes, the first one, we see it.
Okay, very good. I think there is some problems with connection, but anyway.
So you can put it on diaporama?
I don't know why it is paused now. It says it is paused. Okay. You can see my screen.
Yes, we can, yes.
I don't know why. Okay, I think you can see well now. Should be working now.
Yes, we do.
Okay. So, of course, let's start talking about what is El Nino Southern Oscillation. It's an irregular periodic oscillation of the ocean atmosphere system in the Pacific. It is characterized by unusually warm, as you know, by unusually warm temperatures in the eastern part of the Pacific Ocean, opposed to what we call as La Nina, which is, on the other hand, characterized by, as you can see here, by unusually cold sea temperatures in the same area. We're talking about Eastern Pacific, about the water gets cooler when you have La Nina, the thermocline is upwelling, and I'm talking about the area close to Peru, Chile, and Ecuador, and so on. Why is it called El Nino? It was witnessed in the 16th century by fishermen off the coast of Peru. They noticed that around Christmas, because El Nino always occurs around Christmas, between December and January, the water was unusually warm, and as they are very Catholic in Peru, they thought this was a sign, it was a signal of the incoming birth of Jesus. So they called this phenomenon as El Niño de Navidad, which means Jesus Christ, I mean the little boy or Christ child in Spanish. La Nina, on the other hand, is defined, means the little girl, and it was named in this case to refer to the cold phase of ENSO, as we have seen, when the water, instead of after having been warm, becomes cooler than normal. So we will refer to La Nina as the cold phase of the ENSO, and El Nino is called as the warm phase. If we talk about the atmospheric component coupled with the sea temperature variation, El Nino is always accompanied by high air pressure in the Western Pacific, where on the other hand, La Nina has opposite values of this. So these two periods may last several months each, and they typically occur every few years, ranging from 3 to 7 on average. The phenomenon is based on what we call the phenomenon, the Walker circulation. When we have the neutral state, that means neither El Nino or La Nina conditions, the trade winds, the famous trade winds, usually blow west across to east across the surface of the tropical ocean, Pacific Ocean. And they are bringing, in this case, they bring warm, moist air and warmer surface waters towards the Western Pacific. So the water, usually in the neutral state, the water in the Western Pacific is a little bit warmer, and the Central Pacific Ocean waters are relatively cool. So what happens is that warm water is piling off Asia, and the sea surface is about 1.5 meters higher in Indonesia than in Ecuador, in South America. And the sea surface temperature during the neutral situation is like about 8 degrees warmer off the coast of Asia than in the Eastern Pacific. Because there is a phenomenon which we will see very shortly, which is the upwelling of cold water from the deeper levels in the eastern part of the Pacific Ocean. Usually this means that the clouds and rainfall are usually found in the racing area over the warmest area, which is Australia, Indonesia, Philippines, whereas on the other hand, the East Pacific is relatively dry and stable. So this process, which means that warm sea surface temperatures in the Western Pacific pump heat and moisture into the atmosphere above, as we can see here, in a process which is known as atmospheric convection. This warm air, of course, rises up in the atmosphere, and if the air is humid enough, it causes the towering of clouds and rain, and this now drier than the usual air travels east, as you can see here in this animation, before descending over and then condensating over the cooler eastern tropical Pacific. This phenomenon is called as the Walker circulation. This is the neutral, of course, this is what happens in the neutral conditions of ENSO. On the other hand, during El Niño events, as you can see here, what happens is that the opposite happens. So warm tropical waters start shifting towards the east along the equator, towards the South American coast. So the warmest water, they usually are, as you can see here, staying close to Indonesia and Philippines. They move across the equator to the northwestern part of Southern America, which means Peru, Ecuador, and Chile. And this is why El Niño, this is what happens during El Niño phase. This is the reason why El Niño is called as the warm phase of ENSO. On the other hand, as you can see here in this other animation, when La Niña, the cold phase, as we call it, is established, the opposite phenomenon occurs. So the trade winds, which are usually blowing from west to east, in this case, blow even stronger than normal. So this is why this is called the cold phase of ENSO. And it has been, as I was saying before, it has been called as La Niña to indicate the opposite effect of El Niño. As you can see here, there is an increase in the upwelling of cold water coming from the deepest layers of the ocean when La Niña is setting in. So this is just to show you what is the map of the ocean, Pacific Ocean surface temperature during a strong El Niño. Here, this is, as you can see, is warm. It's much warmer than usual, 9 degrees. And when you have La Niña, which is the cold phase, of course, this phenomenon, as you can see, and because we have to consider that the Pacific Ocean is the highest, it's the most important sink of water, of course, this has a very important, significant effect on climate all over the world. We will see this in detail. So this is just to show you what happens during a very strong El Niño episode. This is the famous El Niño episode of 1997-1998. You can see the differences in water temperature, the sea surface temperature. So the water is getting warmer and warmer. We are in February here. Then usually when spring starts to set, the El Niño phenomenon starts to vanish, and then the La Niña phase, the cold phase, starts setting in. And this is what you can see here. This is from satellite observation, so you can see how the water is getting colder during La Nina. So what is important to stress here, that the phenomenon starts in 1997, ends in March 1999. So we have a couple of years of time interval. We have to consider this for what we talk about drought prediction. So this was regarded as one of the strongest El Nino episodes, and it resulted in drought during La Nina and flooding and other natural disaster occurring across the globe. But let's ask ourselves, which are the main drivers of El Nino Southern Oscillation? One of them, for sure, is radiation. As we know, the sun warms the Earth's surface, so the atmosphere, in this case, gets warmer in different ways, of course, according to latitude. We have vertical rays at the equator, we have oblique rays at the mid-latitudes. And so this is the reason why some parts of the Earth receive vertical rays from the sun during the whole year, and they are always warm. Other places, instead, they receive indirect sun rays, so the climate is a little bit colder. Another factor, for sure, for this phenomenon is the wind. But let's see, what is the wind? Wind is air in motion. It is produced by the uneven heating of the Earth's surface by the sun, because the Earth's surface is made of various land and water formations, so it absorbs the sun radiations unevenly. As you can see here, this is what I was saying before. Usually what happens is that warm air, which is lighter than the cold air, rises, the sun hits the ground, so radiation hits the ground gets warmer and warmer, and so because of the conduction and the convection phenomenon, the warm air rises up in the air. And on the other hand, cool air moves in, replacing the rising warm air. So we have a phenomenon like this. And this movement of air, so is what makes the wind blow. So we are talking about a difference of potential from high pressure to low pressure. And this is what happens, for instance, close to the sea. When you have a sea breeze, we're talking about the wind that blows from the ocean towards the land. This breeze, of course, occurs more often in spring and summer months because there is a greater temperature difference between the ocean and the nearby land, particularly in the afternoon when the land has reached its maximum heating from the sun. So there is a difference, there is a gradient in temperature which moves pressure, and that determines the movement of air, and that is why we have the wind. So this is a description of what I was saying before. During the day we have warm air, the land gets heated, so warm air rises up, and the sea is cooler, and so the cool sea breeze gets into the land. On the other hand, during the night is the opposite. It's reversed. The land is cooler, the sea is warmer, so the air goes the other way around. Another important phenomenon, a very important phenomenon we have to deal with, talking about El Nino and La Nina, is the ocean currents. The ocean currents, most of you probably know what we are talking about, are a continuous directed movement of water generated by forces acting upon the mean flow, such as breaking waves, the wind, the Coriolis effect, the temperature, especially most important are temperature and salinity gradients, as well as tides, which are, as we all know, caused by the gravitational force of the moon and the sun. They can flow, these ocean currents are very important because they can flow, they can run for a great distance, making part altogether of the great global conveyor belt, which plays a very important part in determining the climate of many regions of the Earth. One of the most famous examples is the so-called Gulf Stream, which makes somehow northwestern Europe much more temperate than any other region at the same latitude. Another example I will talk very briefly about is the Humboldt Current, which can be found off the coast of Lima, Peru, where the climate is cooler because of course, at the particular latitudes because of this current, which is called the Humboldt current. What is the Humboldt current? I want to show you very briefly this because this has an effect, of course, in my opinion, has an effect on determining El Nino and La Nina. Because of this current, the sea surface temperatures reach temperatures as low as 16 degrees, whereas the regional temperatures of the sea are above 25 degrees in this part of the world at this latitude. This is highly uncharacteristic of tropical waters because of this current. So it is called also, it is defined as the Peru current. And this is a cold, low salinity ocean current that flows along the western coast of South America in the direction of the equator, starting from the Antarctica. It extends from 500 to 1,000 kilometers offshore from South Chile to northern Peru, where these cold upwelling waters intersect warm tropical waters to form the equatorial fronts. This is let's say this is a refiguration of the Humboldt current. These waters are rising up from Antarctica through Southern America. What is important, they are very rich in nutrient and support high levels of primary productivity, marine ecosystems, and fisheries. This cold water is one of the major causes for high productivity of fisheries in this area. I think all of you remember the famous anchovies coming from Chile. And this upwelling brings nutrients to the surface. They support phytoplankton and ultimately they increase biological productivity. This current has a considerable cooling influence on the climate, as I was saying before, of Chile, Peru, and Ecuador. And it is also very, very much responsible for the aridity of the Atacama Desert. So we have here a first example of how marine, the sea currents can have an effect on the weather and the landscape. The Atacama Desert, which is why this happens, because the marine air is cool, is getting cooler, gets cooler because of this current, and thus it's not conducive, it's not generating any precipitation, any moisture. So not even clouds and fogs are produced. This is the Atacama Desert. I think most of you have heard about this desert. It's about a 1,000 kilometer strip off the coast, the Pacific coast of Chile. It is west of the Andes Mountains, and this is the driest desert in the world, as the only desert to receive less precipitation than the polar desert. I'm talking about Antarctica, of course. Most of the desert is composed of salty terrain, salt lakes, sand, and felsic lava. But the desert owes its extreme aridity to this constant temperature inversion, which is due to the Humboldt current and to the presence of the strong anticyclone system of the Pacific. Okay, this is just some this description of the Atacama Desert, which is, you can see here, this is an example of this is a photo of the Atacama Desert, as you can see. Why do we have Atacama Desert? This is due, of course, to the rain shadow effect. I'm talking about the rain shadow effect because this is a very important phenomenon to describe what happens because of masses of air having an effect in this case. What happens is that the mountains of the Andes mainly receive rain from the Pacific Ocean winds. They are blowing, of course, because of this different gradient in air pressure. And what happens is that on the other side of the Andes Mountains, we have hot air, which is laying behind the mountains. And this air, of course, is less dense than the cooler air moving from the ocean, from the Pacific Ocean, due to the Humboldt current. And thus, this part of the area is characterized by lower air pressure. So, because of this gradient, wind will blow in this direction from higher pressure to lower pressure. So the wind patterns move from sea to land, usually in this part of the world. These winds are full of moisture coming from the Pacific Ocean. As you can see here, they are cross over the shore of Peru and they reach the mountains, they reach the Andes. This warm air mass is pushed, of course, because of the wind, is pushed upwards to higher altitudes and where humidity condenses to produce rain or showers. The problem is that these winds are blocked by the high peaks that they encounter. So the rainfall, heavy rainfall, occur only on the southern slope of the mountains, which lie on the windward side of the mountains. What happens on the other side? The mountains, as I said, as you have witnessed, they stand as barriers to the clouds. So rainfall is only happening on the windward side of the mountain. On the leeward side of the mountains, of course, because these mountains prevent precipitation from falling, the air quickly dries up after having this, let's say, discharge humidity, and after that humidity has been condensed, they move down. What is remaining moves down the mountain, and it quickly dries up, going down the other side. So it gains back its warm mass and it absorbs moisture, which is most important. This mass of air absorbs moisture as it moves downwards. So the result is that the great part of moisture of these winds gets exhausted as discharge, lots of rain on the windward side of the mountain. So the air that finally reaches the behind plateau is very, very dry. So, as a result of this removal of moisture in time, the whole area developed in a very, very dry region, as we have seen, devoid of further precipitation due to the action of the descending warm air. So there is no possibility, there is no chance to have other precipitation. So this is the reason why the Atacama region receives very little rainfall. And this lack of rain is responsible for making the Atacama and the bordering regions very, very, very dry. So this Atacama Desert and the other nearby bordering regions are known to be laying in a rain shadow area compared to other regions of Southern America. So why all this talking about the Humboldt current? Because what happens is that periodically from 3 to 7 years on the average, this upwelling of cold water bringing lots of nutrients and fish, and so important for the economy, for the fishery economy and for the climate and for the landscape of the area, is disrupted by the El Niño Southern Oscillation event. When this occurs, of course, the water close to this coastal area becomes warmer. So you can see there is a complete shift in the weather pattern and the environment, giving rise to turbulence and unstable climate. I will show you here what is the effect, the mixed effect of marine currents. This is from NASA. Why it is so important to take into account the marine currents? Because we have to answer ourselves which is the real cause of the El Niño Southern Oscillation event. The ocean, as I said, is not a still body of water. There is a constant motion in the ocean, which is the global ocean conveyor belt. This motion, what is the motion? It is caused by a combination of thermohaline currents in the deep ocean and wind-driven currents on the surface. What happens that is this water circulates because of differences in water density, which are caused by gradients in temperature and salinity. The cold, salty saline water is dense and sinks to the bottom of the ocean, while the warmer water is less dense and remains on the surface. Water is heated near the equator and travels at the surface and into cold high latitudes where it becomes cooler. As we have seen in the previous pictures, it gets its start in the Norwegian Sea, where the warm water from the Gulf Stream hits the atmosphere in the cold northern latitudes. This transfer of heat towards the atmosphere makes the water cooler and makes it sink to the bottom of the ocean. So as it cools, this water becomes denser and sinks to the deep ocean. So more warm surface water flows in to take its place. As more and more warm water is transported north, the cooler water sinks and moves south to make room for the incoming warm water. This cold bottom water flows south of the equator all the way down to Antarctica, as we have seen before. Maybe you can see it here. So moves all the way down to Antarctica. And eventually the cold bottom water returns to the surface through mixing in upwelling water, continuing the conveyor belt which encircles the globe. Now, the Earth global warming and the melting of the Arctic Sea at the both poles can be very effective in changing this, in disrupting this pattern. So this is why we must be very much concerned with climate change. Here we have a still image of the Arctic ice sea when the ice reached its actual minimum, annual minimum. This is of 2017, but I will show you later on some even more updated images. So the yellow line here you can see marks the 30-year average minimum sea ice extent computed from 1981 through 2010. The center, these images are being given by the National Snow and Ice Data Center of University of Colorado. So this center reported that the spread of Arctic sea ice set a new low record for the second straight year, stopping at 5,607 million square miles. That's 5,000 square miles less than last year's record, as observed by satellites, and it is 431,000 square miles less than the average for the winters computed between 1981 and 2010. So you can see how desperate and how dramatic is the situation. Here, you can see from NASA, you can see another, you can see another animation. This is the annual Arctic sea ice minimum area, ranging from, let's say, about 1978, 1980 until 2020. So you can see the shrinking and the expansion of the Arctic sea ice minimum area. So what you can see here in the red line is that the trend is absolutely going down. But we all know this, of course, but still we need to always take into account this data. Why this is important? Because why we have to consider this for climate? Because Arctic sea ice reflects the heat from the sun, and if we have less ice, we will have more heat given off from the ocean and higher Arctic temperatures. So this situation affects weather all around the world by disrupting the jet stream. So we come now into another important aspect of climate and weather formation. The jet streams. What is a jet stream? I think most of you are familiar with jet streams. They are currents of fast-moving air that can be found high in the atmosphere. When we refer to the jet stream, usually common use jet streams, we're talking in this part of the world, at this mid-latitudes, we're talking about the polar jet streams, the most important one. There are also other weaker, the polar jet streams is the blue ribbon you can see here, at both sides of the world. There are some other jet streams which are the subtropical jet streams we can find here in the red ribbon, but they are higher up in the atmosphere, and usually they have, because of their altitude, they have lesser influence, lesser effect on the formation on the weather systems. How these jet streams are created? They are created by a combination of the Earth rotation, the atmospheric heating from the sun, and of course they also are created by the own planet's heat coming from the core. This creates temperature differences and of course creates pressure gradients along which the air rushes. so this is what I was saying before, the effect, for instance, of the sun, the atmospheric heating from the sun. In the northern hemisphere, the polar jet streams can affect the weather by bringing in or pushing away cold air from the poles. When the polar jet streams move south, weather can turn wet and windy. If it goes to south, it will become much colder than usual, which is what we can see here, for instance, over the Northern American continent. What we can see here, if the polar jet streams gets southern, when it moves south, because it is disrupted by its usual pattern, the weather can turn wet and windy, or if it goes to south, it will become colder than usual. The reverse is true if the jet streams moves north, always disrupted by this phenomenon, inducing drier and hotter weather than average as the warm air moves in from the south. This is what happens during El Nino, for instance. We have a significant mass of warm air which moves north across the ocean. So this is inducing drier and hotter weather than average. The warm air moves in from the south, and the polar jet stream is moved north. And this is an example of this jet stream. The variations, as I was saying, they can disrupt atmospheric circulation patterns connecting the tropic with the middle, because they modify the mid-latitude jet streams, the polar jet stream. Of course, by modifying the jet streams, the El Niño Southern Oscillation can affect temperature and precipitation all across the world with different effects. We will see this. And this influence is very strong during the winter, from, let's say, December, January to March, but it can also extend into the early spring. This is an example of how this El Niño and La Niña can affect. This is the polar jet stream. This is the subtropical jet stream. So when the warm water gets in, you can see this mass of warm temperature creates humidity moist, which disrupts let's say the jet streams. But when La Niña gets in, as you can see, it gets moved even further north. The polar jet streams is moved even further north, creating phenomenon as different situations for low and high pressure areas. So how effectively does INSO affect global climate? El Niño, which we can see here, and La Niña alternately warm and cool large areas of the tropical Pacific, which is the world largest ocean, the largest sink for temperature. So the primary location of moist, as I was saying before, rising air is usually centered over the central or eastern Pacific during El Niño, during El Niño, and over Indonesia, as you can see here, and the western Pacific during La Niña. So the moisture during these two different phases of the oscillation is exactly moving from the eastern part during El Niño, moves back, when you have La Niña, moves back to Australia and Indonesia. So this creates different rainfall distribution pattern over the Earth. This is what has been observed in time. Many references show that there are significant deviations from normal surface temperatures, and which can have large-scale impacts on the climate because they significantly influence where and how much is going to rain. So especially from December through February, what happens that as we have seen, this part of the world gets wet and warm. We have floods. We have a lot of rainfall in this part of Southern America. This other part, on the other hand, gets warmer and wet, and the same on the northern part of the American continent. This other part of the world, the western part of the Pacific Ocean, during the peak of El Niño, which is from December through February, gets very dry, gets drought, gets very warm. This is the main reason why you probably will remember the great fire in Australia, which has been occurring last year. This is one of the main reasons why such important fire burst happens in this part of the year in Australia. On the other hand, during La Niña, we have the opposite rainfall distribution pattern. For instance, during La Nina, when the cold phase gets in, this part of the ocean gets dry and cool, and this part of the world, in the Western Ocean Pacific, during the peak of La Nina, that is from December to February, gets very wet. They get rainfall. Indonesia, Philippines, they get storms, they get rainfall, they can get landslides, and so on. But as you can see here, even in Africa, if we go back, you can see that the southern eastern part of Africa gets dry and warm during the El Nino phenomenon, during the peak. And on the other hand, when we have La Nina, this part, southern eastern part of Africa, gets wet and cool, as well as part of the western side of Africa. There is little information, actually, as of now, across the Mediterranean area. As you can see in both slides, not much of research has been conducted over this part. I'm talking about, for instance, the Sahel, the northern part of Africa, the Mediterranean area, and Central Europe. Very little experience of this phenomenon, how this phenomenon, El Nino and La Nina, can affect climate and weather in this part of the world. So this is the main reason why I have been conducting this research. So let's see, as I was saying before, the main consequences of El Nino. We have flooding in South America because we have warmer water in the Eastern Pacific, bringing heavy rain and flooding to South America, Peru, Chile, and Ecuador. Of course, we can also have cholera epidemic and other waterborne diseases. On the other hand, on the other side of the Pacific, we have drought, Indonesia and Australia, because rainfall travels across the Pacific Ocean towards the other side, so they're increasing the odds of drought and fires in places like Indonesia and Australia. On the other hand, and this is of course what we have seen before and in a major detail from December to February. On the other hand, La Nina, strong La Nina events are associated with catastrophic floods in the northern part of Australia and with rainier than normal conditions over southeastern Africa, as I showed you before, and northern Brazil. Whereas on the Central and Eastern Pacific, we have, in this case, when we have La Nina, we have higher than normal pressure, so we have stable weather, we have good weather, and so we have very low moisture, very low rain formation, very low cloud formation. So this is why we have, as I was saying, decreased cloud production, and so we have drier than normal conditions observed along the west coast of tropical South America, the Gulf Coast and the Pampas region of South America, which is what you can see here. So we have this cold weather, this cold water here, also probably influenced by the Humboldt current. We have very dry and cool conditions, so very stable weather, and we have drought, especially in this part of the world, whereas on the other hand, in Indonesia, Australia, Philippines, we have wet weather. And as you can see, we have also some effects on these parts of Africa. But how can effectively, let's get a little bit more into detail. How do effectively jet streams affect climate? Why do we have in some parts, like in, for instance, northern part of Europe, we have wet and windy climate, and in other parts we can have drought, we can have very dry conditions for weather? How this is possible? Jet streams are, as we saw, they are fast-flowing currents of air. They are very important in the weather. As I said before, they are found just below the tropopause at a height ranging between 9 to 16 kilometers. They can be, I'm talking about the polar jet stream, the most important one for climate affecting, which is at mid-latitudes, let's say around 40 degrees of latitude. They can be hundreds of kilometers wide. They are thousands of kilometers long, hundreds of kilometers wide, but they are only a few kilometers deep. They are very, very fast masses of air. They can reach speed of about 300 kilometers per hour. And by the way, they are the currents that are being used, especially by airline companies, to travel faster or slower during the cross of the Atlantic Ocean or in other parts of the world. This is the reason why when you fly to, maybe you have, if some of you have experienced flying to Northern America, it takes like 7 hours to go, 9 hours to go when you go westward, and it goes like 7 hours if we come back. The most important one, as I said before, are the tropical, subtropical jet stream and the polar front jet stream. They occur in both sides of the Earth and they are part of the global circulation. The subtropical jet streams occurs in the atmosphere between 12 to 15 kilometers. It is laying between the descending branches of the Hadley and Ferrel cell. So because it lays in between the two cells, there is little weather associated. The polar jet, which is what is most important for our purpose, forms in a different way. This kind of polar jet stream is sitting between the rising branches of the polar and the Ferrel cells. So it effectively marks the boundary between the cold polar air on both sides of the Earth and the warm tropical air, which is known as the polar front, which you can see here in the red and blue colors. It occurs at a height of between 11 to 13 kilometers. It is the result, as I was saying, of the temperature contrast across the polar front. And the strongest is the temperature contrast across the front, the stronger will be the jet. This means that the polar front jet will be much stronger in winter and it will be weaker during the summer because the contrast in temperatures is higher, of course, during the winter. So the strength of the wind is much higher during the winter. As I said, it develops the effect of the strong temperature contrast blowing at the tropopause level. And to explain the phenomenon, I would like to show you what is happening if we can think of two columns of air. The warm column of the column of warm air coming from the subtropical and tropical area, and the cold column of air, masses of air coming from the pole. Okay, so if we think of these masses of air as two columns, the warm air is coming from the tropical area and the cold one is descending, as I said before, from the pole. They exert an identical pressure on the surface on Earth. If we consider this is the Earth, so the mass of warm air and the mass of cold air coming from these two different areas, they affect an identical pressure on the surface of Earth. They are both located at the tropopause, but they have different heights. This is very important. They have different heights. The top of each column is bounded by the tropopause, and the shorter column of cold air exert the same surface pressure as the taller column of warm air. Why? Why this is happening? Because in the cold air column, the air is heavier, is more dense. And this means that atmospheric pressures decreases more rapidly according to the height. On the other hand, in the warm mass of air, the warm air column, the pressure does not decrease as rapidly with height because the warmer air is less dense, is less heavy. So this is why the gradient is different. So both columns of air are exactly at the same atmospheric pressure because they are located at the tropopause. What this means? This means that if you were to climb at the same height, at the same level of height in both columns, you would have a difference. You would have a gradient in atmospheric pressure. So you would be at a lower atmospheric pressure in the cold air column and at a higher atmospheric pressure in the warm air column. So you have a gradient at the same height. So this pressure created by this temperature gradient, create a pressure gradient force, which forces air to move. So this pressure gradient force acts usually is pushing from higher to low pressure. So theoretically, in the northern part of the hemisphere, the Earth, the air would be flowing from south to north. So this theoretically should be the movement from south to north of air. But on the other hand, if we consider the Coriolis force, which is determined by the Earth's rotation, the air is moved to the right in direction of motion in the northern hemisphere. So this is the reason why the wind is blowing in this part of the world, in this area, in this direction, and on the other hand, it moves to the left in the direction of motion in the southern part of the hemisphere. So, in both parts of the hemisphere, the jet stream, the polar jet streams flows parallel to this temperature gradient between the cold and the warm air, moving from west to east. And theoretically, it encircles the Earth in a continuous line. As I said before, these jet streams are very, very thousands of kilometers long. But in reality, this jet stream is more, this is an image, it's more broken up. Why? Why it is broken up? Because we have a differential heating of land to sea masses. They lead, sometimes they lead to west, they lead to west to east temperature contrast, as in this case, as you can see here, or to north to south temperature contrast. So the polar jet stream, which is a fast-flowing thermal wind, which strongly influences weather over Europe, forms due, as I said, to this very strong temperature contrast. The strongest the temperature gradient, the stronger will be the jet. So as I said before, it will be stronger during winter than during summer, as the pole get cooler during the winter months, so increasing the temperature contrast. In the northern hemisphere, this is very important for the determination of climate. The polar jet tends to be further south in the winter time, and it moves further north during the summer. This is why this happens. This is due to the inclination of the Earth and to the fact that during the winter, the northern hemisphere tilts away from the sun, as we all know, while in the summer it is tilted towards the sun, and the opposite happens on the other part of the hemisphere. So if we consider like if it was straight, a west to east flowing jet stream would not have much impact because it would be stable, as you see in this slide, on the development of new weather systems, or neither would be strengthening pre-existing ones. But when a jet, as the polar jet stream meanders north and south, what happens is the air accelerates and decelerates around the bends. So what happens is that it's accelerating and then decelerating, then accelerating and then decelerating around the bends in the flow. So these areas of changing speed, this is very crucial to understand. These areas of changing speed are what they call the development areas, where in the part of the jet stream where the air is accelerating, more air is leaving than entering a certain point. So this means that at this certain point, the air is being depleted. To fill this depletion, the air flow below rises up in the atmosphere, and winds at the surface, because of the gradient, this movement of air, the winds at the surface converge to this rising column of air, which causes the surface pressure to fall. So we have a low pressure areas because of this meandering of the jet streams. So the pressure here is falling behind average, so that a low pressure systems can be developing or deepen even further. So this is the main reason. So we have come to an end now. This is the main reason why at mid-latitudes, like northern part of Europe, the low pressure system usually occur on the northern side of the jet streams. As you can see here, in this part of the northern part at mid-latitudes of Europe, whereas on the other hand, more settled and warmer condition, high is for high pressure. This is the main reason why, because of the meandering of the jet streams, this is the main reason why more settled and warmer condition can be found to the south, for instance, in the Azores and in the Mediterranean area. And this is the main reason for the wet and windy weather that often are experienced in northern part of Europe, and on the other hand, for the warm and stable weather conditions, which are instead occurring, for instance, in the Mediterranean. Now, if we consider a stationary jet stream pattern, this will bring, as we have seen before, I showed you before, the mechanism by means of which the jet streams can develop low pressure systems. So if we have a stationary jet stream, we will have stationary low pressure systems moving always in the same region. That means northern part of Europe, northern part of America, or the American continent, and so on. But when warm air, for some reason, is moving up, as we have witnessed to happen, for instance, when El Nino develops, the jet streams moves further north, upper north than normal. Or could happen that cold polar air, because of this shifting in the jet streams, cold polar air is easier to move further south. So this can change, this has an effect on the prevailing west to east flow of the jet stream pattern. So just to show you, what happens is that warm masses of air are rising from the ocean, they have an effect on the jet stream, and they are so altering the usual low pressure determination of the determination of low pressure areas or high pressure areas. So this changes definitely the prevailing west to east jet stream pattern, causing the jet streams, as it is defined, to buckle, driving depression towards different regions or blocking their movement altogether. So if you see what happens, I just want to let you see physically what happens is that the jet stream is effectively buckled, and so it is alterated during this phenomenon. So at the end, although a jet stream is just an area, we could say it's just an area of fast flowing air, it has, as a matter of fact, fundamental effects on our weather. I just will show you, this is a nice, interesting video that somehow resembles
weather patterns are caused by
what I've been saying. Can you hear? I hope you can see it.
Those lead to pressure differences, which, combined with the rotation of the Earth, force air to move around the globe. We feel this as wind. Jet streams are very strong winds in the high part of the atmosphere, anywhere between 5 to 7 miles up. The speed of this stream can be more than 200 miles an hour. These bands of air are typically thousands of miles long and hundreds of miles wide. In the northern hemisphere, they broadly flow from west to east and shift north to south according to the season. In wintertime, the temperature contrast between cold polar air and warm tropical air is greatest. The jet stream is strongest at this time of year. These boundaries are also where weather fronts generally develop. A low-pressure stream is like a giant funnel of wind spiralling inwards and upwards, forcing warmish air towards the centre and then to rise. As this moist air rises, it condenses to form clouds. Over the North Atlantic, the jet stream typically steers depressions in a west to east direction. A stationary jet stream pattern over the Atlantic will bring frequent depressions to the same region. Sometimes warm air moves further north than normal, or cold polar air moves further south. This can change the prevailing west to east jet stream pattern. This causes the jet stream to buckle, causing depressions to move towards different regions or blocking their movements altogether. Therefore, jet streams can have a fundamental effect on our weather.
Now, let's come to, I needed to do this introduction to get a little bit more deeper to what is the result of my research. Now, if we consider some of the most intense drought phenomenon episodes, we can certainly remember the one started in 1997 and then with El Nino in 1997. But by sure, it was one of the most intense was the 1998 drought in the Eastern Mediterranean Levant region. We're talking about countries such as Cyprus, Israel, Jordan, Lebanon, Palestine, Syria, and Turkey. And it has been considered as probably the worst drought of the past 9 centuries. And you can see here, there's a scale depicting the terrestrial water storage anomaly. And you can see, for instance, in Egypt, it was very, very strong. In this part, in Lebanon, Syria, Israel, and so on. But also in Italy, as you can see here, there are some areas in Spain and Portugal. So the whole Mediterranean area, 1998 and 1999, I can say. How did they reconstruct this? They observed they studied the tree rings of the inside the vegetation as a part to understand the region's climate and what was happening when water was shifting from or to another area. So the thin rings were indicating dry years, while thick rings would show years when the water was abundant. Now, if we take a look, this is an interesting slide because this is showing the rainfall index from June to October, starting from 1900 until 2020 in the Sahel region. This is a rainfall data series from 1900 to 2020. As you can see, the worst, probably some of the worst episodes was the 19 people from, I don't know, maybe the young professionals are too young to remember this, but it's very famous, the very famous drought of 1973, 1974, and 1975 in the Sahel was dramatic. The 1984 and following years, 1988, 1989, until the 90s, was another dramatic, as a matter of fact, was another dramatic period of drought. And the following years, as we have seen, you can see here another part of very low rainfall, that is 1998, 1999, and so on until year 2000. So this is an example. This is just to show some of the worst rainfall years in the Sahel. I came up with this idea to conduct a study. This is Italy, of course, in a particular region. This is the region where I'm living. This is called Basilicata, and it's a 10,000 square kilometers region. Asking myself, if we know all of this information, we have all of this information about El Niño, La Niña, we have indexes to monitor and to follow what is happening in that part of the world in the Pacific Ocean. Can we possibly correlate this phenomenon as we have witnessed to what happens in this part of the Mediterranean with rainfall? Is it possible to have drought prediction? This is the main question. So I have been examining rainfall in this region. This is a digital elevation mode of this. As you can see, there is a small part of the region which is rich in water resources, which is plain. This is called the Metapontum Plain. But as you can see, most of it, about more than 2/3 of this region, is mountainous and hilly. And it is rich in water resources, rivers and streams. They are collected by means of several infrastructures. The regional government has been adopting in the past 70 years, many dams and reservoirs to collect water and distribute it for the irrigation that agriculture which is taking place, especially in this part of the region, in the plain areas, of course. So, as you can see, there is a complex system of reservoir. This is the most important one. This is the Monte Cotugno Dam. This is about 400 million of cubic meters. Then we have this other important dam and reservoir, which is called the Pertusillo Dam. It's in another basin. This is in the Sinni River basin. This is in another basin, the Agri River basin. And the most important one, the three most important ones, we have different reservoirs, but of course these are the most important. This is the San Giuliano Dam on the Bradano River. So all of the river, almost all of the river, have been intercepted and have been built. The regional government and the Italian national government in the 50s, starting from the 50s, they conceived and they built infrastructures in order to accumulate water and deliver it for irrigation in this part. This is a very high cash, intense, high cash crop agricultural area. So it is very important, it is strategical to have water in this part where we have about like 5 to 6 millimeters of evapotranspiration per day. in this part of the region, rainfall, average rainfall is about ranging from 500 to 600 millimeters per year. So irrigation is absolutely strategic. This is just to show you the impressive networks of canals and aqueducts. Canals there, we don't have canals anymore. We all have pressurized, or almost everywhere we have pressurized systems, or we are also delivering by means of these three important dams, but also we have other minor reservoirs. We are also giving water to the bordering regions such as Calabria and Apulia. As you can see here, reservoirs, weirs, we have and we have multiple purpose water delivery, we have civil purpose and irrigation purpose. So you can see the plain coastal area is very much scattered with irrigation systems. This is to show you what is the rainfall. As I was saying before, we are ranging in this part, which is bordering the Tyrrhenian Sea, so under the influence of the Atlantic Ocean moisty air, we can have in this part of the region, we can have from up to 1,800 millimeters per year until sometimes 2,000 millimeters per year. And on the other hand, we have the rainfall falls down up to 500 to 600 millimeters per year. In blue, this is the red dots is the network of pluviometry and gauging stations for recording of rainfall. And the blue ones, the big blue dots, are the stations that I have been using for conducting this study of drought prediction. As you can see, probably you will see it better here. This is the red dots here are the stations, the pluviometry station I have been using. They are, each one of these is in different river basins. So this is in the Sine River, this is in the Agrisaur River, this is the Caruna River, this is Basento, and in the Bradano River, which is a very long river basin, we have three stations: north, central, and south. This is the river basin, as I said before. As you can see, the Bradano River, the green one, is the longest and the widest. It's more than 3,000 kilometers, and all of them. Altogether, we are covering an area of about 9,000 square kilometers. These are the main issues, the main characteristics of the stations I have been using. As you can see, they are reported here. Again, this is the elevation model. So we are ranging from about 1,000 meters above sea level to 600 kilometers to 300 meters above sea level. Sorry, 300 meters above sea level. So you can see here, Noepoli is 676, 800, and so on. These are the latitude and longitude features of this station and the different basins. Why I chose these stations? What was important was to have the most possible continuous data set of rainfall. The information I gained is to have daily 24-hour rainfall precipitation data. So starting from January 1st, 1951 until December 31st, 2020, data have been recorded, rainfall data, daily rainfall data have been recorded in this 70 years time span. This is the description of the average rainfall of the different stations, where we are ranging from Noepoli, which is on the average of the 70 years, average is about 700 millimeters per year. Then we are slowly going eastward to Irsina, which is in the eastern part, which is here. And so you can see there is a significant reduction of rainfall. Why? This is very important in order to have a situation. I wanted to be sure that the picture I was gaining from conducting this study was effectively taking into account all the spatiality and the variability in rainfall that is occurring in this region. So what I did was to, as you can see, there is a very high correlation. It's about 0.9. So there is, what I wanted to know is this 700 millimeters significantly different from the ERCINA data, which is 586. So I conducted analysis of variance between the two stations, between Noepolin and ERCINA. And the F value is, of course, higher than the critical F, and the P value is very, very, very low. So I can reasonably say that the two stations have different averages, and these two different averages are significantly different one from each other. So, this is important to know that the plan of the research is effectively taking into account spatial variability of rainfall in the region. What was the main index that has been used to correlate El Nino with rainfall? There are two basic index, which is the Oceanic Nino Index, which has become the de facto standard index that the National Oceanic and Atmospheric Administration uses to identify warm and cool phases in the tropical Pacific Ocean. Usually in red are depicted very strong El Nino episodes, and in blue, very strong La Nina. You can see here, interesting enough, that 1998 and 1999, 1988, 1989, 1973, 74, 75 are all associated, as you will remember probably, as I shown before, the drought years in the Sahel are associated with La Nina episodes. So we have a first indication of how La Nina and El Nino, on the other hand, in the floods, are affecting drought. So this is the main index I've been using, the Oceanic Nino Index. There is another, of course, this is the 3 months sea surface temperature mean, about anomaly for the El Nino 3.4 region, which is this part of the Pacific Ocean. There is another index that is usually used. Of course, it is based on the difference of temperatures between these two regions. I forgot to say this. It is based on sea surface temperatures gradient. So it is based on sea surface temperature. The other index that is also sometimes used is the Southern Oscillation Index. This has been calculated by the Australian Bureau of Meteorology, but this is based on a gradient of pressure. So what is it doing? It is taking into account the surface pressure gradient existing between the western and the eastern area of South Pacific. And it is calculated as a normalized difference between the pressure anomalies recorded between Tahiti, that is the eastern part of Pacific Ocean, and Darwin in Australia, the western part of Pacific. So it is providing an indication of development and intensity of these two events in the Pacific Ocean. So ONI index is based on differences recorded in the sea surface temperature, and the Southern Oscillation Index is based on gradient of pressure. In this study, in this research, I have been using the Oceanic Nino Index based on temperature. Now, going towards results. This is Noepolin Station, but of course, research has been conducted over these 70 years, daily data, rainfall data, 24 hours data, cumulated in monthly data, accumulated in yearly data. This is for Noepolin Station, the first station that we have seen, the most western station, pluviometer station, the gauging station. And this is the variation of rainfall starting from January 1st, 1951 until December 31st, 2020. Of course, this is a yearly accumulated values, so they are yearly data. So you can see there is a kind of decrease. I try to also to derive a correlation, but it's not sufficient because it's quite poor. It's 0.4, but still it gives us an indication of what is happening and how the climate is changing. So this is very important to consider, because we are trying to predict to have methodology, to have an instrument as a support decision tool for decision makers. But we have to take into account that the climate is currently changing. So what we can see here, starting from 1951 until 2020, there is a slow decrease, let's say in yearly data of rainfall until the 1988, 1989. But then there is a slow upsurge of rainfall. What is interesting to note is that there is a different, it's more kind of scattered. So what is happening, probably this is very common, it's very well known, there is an increase in the intensity of the rainfall. But I would like to just very briefly let you see that some of the worst year, I mean the driest year, are the ones that we have seen before. Like here, 74, 75, we have 88, 89, we have 98, 99. I mean, not the 2017 was another most recent years after the 2015 year of El Nino. And also that some of the highest values of rainfall, according to this station, so above the average, let's say here is more than 1,200 millimeters per year, have been occurring during El Nino. But we will see this in the following slides. What I did was to come up with an idea. I asked myself, can we try to correlate in a first basis what is happening in time, piling up from the highest value of rainfall, which is 1951, until to put down in a decreasing manner the rainfall. So what I did here is to show in yellow years who are laying underneath the average. Let's say the average is, in this case, is 700, but significantly under the average. So starting from 600 millimeters per year, and see which were the correlated years. And then the lower than average, driest years, so we're talking about an average of, calculate a measured value of 300 to 400 until 500 millimeters per year, and see which were the years that were recorded. You can see that, as I was saying before, 1988, 1989 is here, 1975 is here, 1998 is also here. The drought that NASA has indicated as one of the worst years for drought. So this induced me to further investigate if there is a correlation between these two phenomena. So next thing I did was to correlate rainfall. I plotted rainfall, annual rainfall, with cumulated oceanic Nino index. This means that I cumulated during the year the values, positive and negative values of oceanic Nino index. And this is the evolution in time, which is not really saying much. I mean, it's not really giving us a response, but still we can see that, for instance, in 1999, 1975, the cumulated ONI index occurring during the year is very low. Of course, it is very low in 1974, and so on. So I was getting a piece of information step by step. I did also, of course, the other way around. I tried to see what was happening if I was plotting cumulated ONI starting from the highest level of cumulated oceanic Nino index, which is the one that has been recorded in 2015. This is more than this is 17.50 in 2015 El Nino. It was recorded, this cumulated oceanic Nino index. This is the first time, I think, I haven't found papers who are or methodologies who have been dealing with accumulated oceanic Nino index values. And on the other hand, I had the lowest values of cumulated oceanic Nino index, which is the one that has been recorded, if I can see well here, should be in 1999. And you remember I showed you before that 1998 and 1999 was the worst drought period that NASA has been recording, according to the vegetation index and to the level of thickness of the tree rings. So I gained another important information here. So this is the driest years. The highest years of rainfall are somehow, some of them are like 1972, 1953, 1957, 1959, are based on the left part of the graph, which is the part characterized by highest values of Oceanic Niño Index. Oceanic Niño Index high values are the red ones. This means the warm phase. So we can reasonably start to guess, but we have to verify this from a statistical point of view. We can start to guess that when we have El Niño high cumulated index values, rainfall is going to increase. On the other hand, when we have negative, so cold phases of ENSO, that means La Niña, we are very likely, very probably we are going to face drought. And this is, again, some exceptions. There are some particular low rainfall years, even in the highest part of El Niño index, but there are few, as you can see here, much more here in this part of the graph. And of course, there are some also anomalies in rainfall during the La Niña phase. This is the database. This is just a glimpse of the huge database that I have been using. What I did from 1951 was to put together rainfall and the Oceanic Niño Index, registered as a mean of, for instance, in this case, 1951, of December, January, and February. I showed you before that the Oceanic Niño Index is the average, is the mean of the 3 months calculated during this period, during the 3 months period. So you can see the evolution. Of course, let's take, for instance, and of course, it was associated with the rainfall that has been recorded during the month. For instance, in this case, the central month, in this case, is January, February, March, April, and so on. If we go, for instance, to 1972 was a very strong El Niño episode, as you can see here, because the cumulated value, if we sum all the values of Oceanic Niño Index across the month, we gain, let me take away this just for a second. You can see that it is 11.10 at the end of the year. So cumulated value of El Niño index is quite high. On the other hand, when La Niña sets in the following year, that is 1973 and 1974, you can see that the values, after having peaked like 2.1 in October, November, December, and January, they start, and 1.8 in January, they start going down and they start to become negative. So because La Niña phase, so there is a different gradient in temperature, because this index is based on temperature. So there is a negative gradient of temperature. So this means that the La Niña phase is starting to set in, and you have a negative peak like -2 in December, which gives us a cumulated value of -7, and in 1973 of -10. And what is this? What does this mean? How is the rainfall in 1973, when the negative cumulated effect was almost -11? We have 577 millimeters, which is different from 700 millimeters of average. Still, I mean, we are gaining information, but we don't know yet if this is statistically significant. So, of course, I could show you some other examples, like, for instance, this in 1999, -14 cumulated value of Oceanic Niño Index. And the rainfall, associated rainfall in 1999, cumulated rainfall was 500 millimeters, even lower than 1973 and 1974. We can go to 2000 and, for instance, 2007 was another year of El Niño, and we have, the El Niño was in 2006, I think 2007. Anyhow, the accumulated, as you can see here, in 2007, we have -7, and the rainfall is very low, 464 millimeters. In 2008, accumulated value is -9, and rainfall, of course, is lower than average. The strongest episode of El Nino was in 2015, 17.70 of cumulated value of Oceanic Nino Index. And the following year, in 2017, it was not a very strong La Nina because we only have -2.10, but still the effect was very, very significant because we have 480 millimeters per year in 2017. I just want to raise your attention that whenever we are talking with El Nino phenomenon, like it's happening in 2015, like we have seen in 2072, and then what happened in 73, 74, or in 1987 was El Nino, and then we have very low rainfall 2 years after. So there is a 2-year interval of time, which is the interval of time that is the one that is needed for El Nino to cease its phase and for La Nina to start settling, to develop, to deploy the effect. So this means that if my assumption is real, if my assumption is statistically significant from a mathematical point of view, this means that we have like 1 year to 1 year time enough to predict that is coming drought, that we are going to face significant reduction of rainfall. So what I did, this is the statistical analysis. What I did was to show, I started piling values of, let me take this off. I started piling values of cumulated Oceanic Nino Index from the highest, which is the one recorded in 2015, until the lowest, which is the one recorded in 1999, -14. So we are starting from 17 in 2015, then we have 15 in 1987, 14 in 1997. These are all years of El Nino. 1982 was another strong El Nino event. 1972 was another strong El Nino event. Of course, why? Because we are witnessing that we have very, very high values of cumulated Oceanic Nino Index, positive. So we are in the warm phase here. You can see, that's why I depicted in red. What happens if I consider years of values ranging from 17, almost 18, until 8? So in order to have a comparison, what I did was to divide the two extreme peaks of the progression. So what I did was to divide the highest value from 18 to 8, and the most negative one from -7 to -15. And in the middle, we have average values of cumulated only. I mean, not as strong values, because as you remember, I showed you at the beginning of my presentation, there are phases in which the ENSO phase is neutral. So these are years we cannot consider. For instance, when the accumulated only is ranging from 7 until, for instance, 0, in this case, or when it is very low, negative, until -6, -7. What I did is to find, in order to have a threshold useful for drought prediction, I put different threshold. I started with 10, -10, and +10, but then I saw that I could also get a little bit lower. Why? It is very important, because the lower the threshold, the better the situation. The better would be the time I will have in advance to predict drought, and thus to have decision makers or agencies who are running reservoirs to save water. What I mean, what I want to say is that if I know that El Nino is, by monitoring El Nino values, if I know that the El Nino is growing very, very intensely, I can expect myself, according to my assumption, that in the following year or the following 2 years, there is going to be a very strong La Nina. I will show you this in the next slide. And thus, I need to prepare, to be prepared. I know that there is going to be a significant reduction of rainfall, so I need to save water. And the water that is kept in the reservoir needs to be stored. You cannot use it, for instance, for orchards, for vegetable crops. You need to give that kind of water to orchards. Because, why? Because in this case, because you cannot just use groves, orchard groves, peach orchards, grapevines, other kind of fruit tree crops, because they are fixed. I mean, they are there. And if you lose those, you will lose a lot of money. I mean, farmers will lose a lot of money. On the other hand, you can advise farmers, if you want to grow strawberry, salad, cucumber, whatever other kind of horticultural crops, you can do it, but that is based on your risk. I cannot give you any water because I can reasonably expect that in a year time or 2 year time, I'm going to have drought, according to what is the level of the Oceanic Niño Index. So I don't know if I was able to explain what I did in my methodology was to check, is this average value, the average value of this set of year of Oceanic Niño Index is, the average value of rainfall is 785.12. On the other, and this year, in the mean, in the middle values is 685. In this kind of the distribution, on this part of the distribution instead, the average value is 656. Is this value, 656, significantly different from this value? So if this is true, I can reasonably assume that El Nino has a direct effect on rainfall, increasing, even though slightly, increasing precipitation, because this is for Noepoli station, where the average is 700. So we reasonably can expect that when El Nino is setting in, the rainfall is going to be higher. And when La Nina is setting in, rainfall is going to be lower, even touching points of 400 millimeters, 500 millimeters, as you can see. There is a kind of variability. Also, in 73, for instance, even though we had a very negative value of cumulated ONI index, still rainfall is high. So there is some kind of variability because, of course, rainfall determination is not only function of a single factor, but still almost at 80%, 90% is depending on El Nino. So what I wanted to know is this value, this average value is significantly different, statistically different from this value? So again, what I did was to conduct an analysis of variance, a single factor analysis of variance. I compared the group of years and rainfall data with Oceanic Niño Index major than 8, with values, years, rainfall, and cumulated Oceanic Niño Index minor than -8. The first result, and to see what is the significance of these two, if these two values are different. Sorry, just a moment. So the first result of this statistical analysis tells us that the variance recorded within the group of data belonging to years characterized by -8 values of ONI is significantly lower than variance calculated for the ONI major than 8 group of years, which is what you can see here. As you can see here, variance inside groups of years which have been characterized by a value of Oceanic Niño Index major than 8 is 40,462. Instead, variance inside the group of years and rainfall data characterized by ONI minor than -8 is much lower, is almost half. So what does this mean? This is the first result. This means that reasonably talking, I can assume that this methodology, this approach is much more reliable in order to predict drought rather than predicting increased rainfall. Still, there is a kind of information we can gain in order to prevent floods, in order to prevent rainfall, extreme episode. But it's much more reliable because variance is lower in this group of years. It's much more reliable in order to predict drought. Another important consideration that, yes, this is resuming what I was saying. And this is, of course, what is most important. This is according with what has been found in recent literature. There are some other papers, there is a couple of them, for instance, that have been conducted in Spain that show, but also in other parts of the world, they show that predicting drought is much more reliable than predicting floods, according to the monitoring and the calculation of the Oceanic Niño Index. Another important, so yes, this is just to show that it's much more reliable for predicting drought rather than floods. As it can be seen, F value is higher than the critical F value, and P value is lower than 0.05. So this means, according to the result we have been gaining from the analysis of variance, we can reasonably reject the null hypothesis. This means that the rainfall occurred in years when cumulated only was lower than -8 is significantly inferior, minor, than the average from the statistical point of view, as well as it is significantly different from rainfall that has been occurring during periods of time characterized by only cumulated values which are major, are higher than 8, which is what we can see here. F value, of course, is higher than the F critical, and the P value is very, very low, and it is lower than 0.05. So this means that my hypothesis null can be rejected. So the two means, the two values, the two group of years are significantly different and are significantly different from the average. I'm going to conclusion now. This is the evolution of the Oceanic Niño Index, the blue line are the values, monthly values starting from 1951 in January until 2020 in December. This is the oscillation. As you can see, the blue line is the oscillation of sea temperature in time. From 1951, Oceanic Niño Index is starting to be recorded from 1951, January 1st, 1950, I think, actually, until today, until December 2020, but it can still be monitored, of course. And one first information we can see, we gain from this graph, I plotted this data, we can see that there is an increase. There is an increase in sea temperature because the lowest average value in 1951 was 26.01. The highest average value recorded was 27.56 degrees in May 1951. The highest value recorded in May 2020 is 27 degrees, 0.9, almost 28 degrees. So 1.5 degrees, almost 1.5 degrees more higher. And the lowest, which is more dramatic, even more dramatic. That's why we have to consider, if we want to approach this problem, we have to always consider we are dealing with climate change scenarios. The lowest value of temperature, of the sea temperature, is 26.6 recorded in December 2020. So there is a difference, as you can see, of 0.6 degrees. Sorry, I said 1.5. Sorry, here is 0.4, but here is even higher. But the green line instead is the Oceanic Niño Index, as you can see here, evolution in time, and you can see the red triangles are the strongest peaks of the Oceanic Niño Index, and they are telling us this has been El Niño. There has been El Niño episode. For instance, this one is very strong in 1958, in 1965 in November, 1972, as I said before, 1982, 1987, 1997, 2009, and 2015. Now, just to talk about climate change, you can see there is also an increasing trend in the peak of the Oceanic Nino Index value recorded. So, of course, this is according to the increase in the temperature of the Pacific Ocean. Of course, we have higher values in time, increasing values of Oceanic Nino Index in time. Why? Because the temperature of the ocean is increasing, has been increased. So we are, it's logical to expect that the Oceanic Nino Index is going to go, and we are willing, we have to consider that most likely El Nino episodes are going to be stronger and stronger because they are depending. Of course, if we consider the sea surface temperature as an index, we can expect that these episodes are going to grow in intensity and strength. The lowest values of Oceanic Nino Index, as I said before, are, you can see here, they are 1988, 1973, 1974, 1975, 1999, 2010, 2017. And going back, you can see that there is a kind of more distribution in this part of the graph. It was kind of more rare in this part of years, and now it's becoming more and more. I'm talking about La Nina. This is La Nina. This is negative values of Oceanic Nino Index. So you can see there is a kind. It was rare. It was kind of rare before. More, much more frequent now. La Nina negative values of ONI index are becoming. Looks like they are becoming more frequent. So we also have to expect that drought episodes might increase in strength, in frequency, and intensity. This is the same kind of values, rainfall and ONI. This is being plotted on a monthly basis, but it's not really saying much, not much. But we can see that rainfall. Just to show, I just want to show you that the highest peaks of rainfall are associated somehow with the highest peaks of ONI, of El Nino. But the data here are too scattered because these are monthly data, so I will not spend too much time. These are the final slides. If we plot, what I did was to plot for every single station. This is Noepolis station, but of course this has been done for all of the other stations. If we plot rainfall evolution in time from 1951 to 2020, we plotted against the cumulated Oceanic Nino Index evolution in time, we can see what I was saying before. So that when we have, seems like when we have strong El Nino, like in 72, in 82, in 97, there is a kind of increase of rainfall, but it is not as clear, this result is not as clear as when we compare low values of Oceanic Nino Index, that means La Nina, with very low rainfall events here. In this is 1975, and we have 500 millimeters. 1988, we have 450 millimeters. 1999, we have 505 millimeters. This is the value of 1999, and this is 500 millimeters. In 2007, negative value of cumulated Oceanic Nino Index, and we have 464 millimeters. In 2017, which is La Nina year, so 2 years after 2015 strongest El Nino episode, we have 452.6 millimeters of rainfall fallen during the year 2017. So there is, and this is of course a trend that has been measured for all of the other stations. This is Stigliano station, this is San Mauro Forte station. You can see the trend is very, very similar. Albano di Lucana station, Palazzo San Gervasio station, Monte Scaldoso station. Of course, there is some of the stations, especially this one, is missing. There are some data missing, but some of the phenomenon is being, like for instance in 2017, most of them are being reported by other stations. And Irsina station as well, which is the last one. All the pattern is similar for all of the stations, but anyhow, it has been supported. This hypothesis has been supported, of course, by statistical analysis. And so the last three slides. What about, this is for rainfall. We have been seeing so far what has been let's say the behavior of rainfall and when plotted against Oceanic Niño Index cumulated values in time. What about what has been happening inside the reservoir? Because as I said before, reservoirs are strategic for agriculture, for irrigation in this part of southern Italy. Let's see, this is a graph which shows the yearly evolution of water resources kept inside the Monte Cotugno reservoir, which is the biggest one, the one for 400 millions of cubic meters from January 1st, 1998 until June 20 of 2021. You can see there is an evolution, of course, in time. There are some negative peaks. Let's see which kind of years are these peaks. For instance, this one is 1998. There is a slow surge, but then those of you who are familiar with dams and reservoir management don't know that after you have been using the water kept in the reservoir, it is very difficult to have water level rise up again because the basin gets dry, water is depleted. So there is a second negative peak in 1999, in 2000, and of course also in 2000. You remember that 2007 was an El Nino year and 2008 is a negative value. But of course there are some others like in 2017. I showed you before the 2015, and you can see it here actually. There is 2015 was an El Nino event and water is rising up, is piling in the reservoir. But then in 2017, again, you have La Nina and you have drought and you have very low rainfall and of course level inside the reservoir because the water that was available has been used for agriculture and for civil purposes. So, and this has been witnessed also for the Pertusillo reservoir, which is in the Agri Basin, the same negative peaks, as you can see. 2007, 2017. And this is the San Giuliano reservoir. Same kind of data, same pattern, same negative peaks, with different accents, of course. But you can see the pattern is very much similar for all of these three major reservoirs. So what I want to say, what does this mean? This is the proof, this is the real effective proof that when we have very strong El Nino events, we are reasonably likely to expect very strong La Nina events. And especially when we are facing La Nina events, we have to deal with drought, with significant anomalies, significant deviations from the average of rainfall. That means that we will have lower water to be kept inside, to be accumulated inside the reservoir. This means that if I know that in 2015, for instance, I have had a very strong El Nino, I need to save this water because I know that in the following year and in the following second year, I might have drought. So I need to keep this water and I need to preserve it only for civil purposes, which is the primary use of water, for drinking, for civil uses, and for that kind of crops, high cash crops, high income crops, such as orchards, orchard groves, fruit tree crops, which cannot be removed. So you need to give water to this kind of crops. You can advise farmers, irrigation agencies, irrigation bodies, irrigation and land reclamation consortia. They can advise. They need, based on this methodology, they can predict that is going to be happening drought. So they should be advising farmers. Okay, you want to plant, you want to seed strawberry, you want to have salad, you want to have horticultural crops, whatever you like, but I cannot give you any water during the following year. Next year, I will not give you any water because I have to preserve that kind of water for drinking, for civil purposes, and for fruit tree crops, which are there. You cannot remove them. And if you lose fruit tree crops because of drought, you cannot give water to them, then you will lose the plant and you will lose hundreds of thousands of euros as investments and gained product.
Marco.
And this is the end.
Marco.
Yes.
Excuse me. Can we give the floor to the participants if they have any questions?
I'm finished.
Okay, thank you. So, thank you.
Thank you.
Thank you for this excellent presentation. I think we can take a few questions if some participants would like to.
Yes, of course.
Yes, we have a question from Morocco.
Bonjour tout le monde. Bonjour, Monsieur Marco.
Morning, Mr. Marco. Thank you so much for this information, rich information. My question is, what is the effect of El Nino on the African continent? Thank you. I'm going to speak in English, but I would be at ease to speak in English.
On peut parler en anglais?
Oui.
Okay. As I have shown before, maybe I can show you before. I can show you again. What I wanted to do is to have a first pilot area to verify the consistency of my hypothesis. My hypothesis was that, as already witnessed in other parts of the world, when El Nino and La Nina are setting in, you have to expect significant anomalies, significant variations in rainfall. When you have El Nino, you have increased rainfall. When you have La Nina, the cold phase, you have to expect reduction, significant reduction of rainfall. Sometimes this can be occurring, can be extended into real drought periods. As you have seen, if you want, I can show you again the slide. If we look at what happened from 1900 until 2010 in the Sahel area, but that of course is also applying to northern African countries, to the Maghreb. You have seen that the same low rainfall recorded for the Sahel, and of course it's very reasonable to expect that it happened the same in the Maghreb, and because it happened also in southern Italy. We are very close. Southern Italy is very close to the Maghreb, is very close to Sahel. I'm talking about macro area, climate area. So I think that this kind of approach, this kind of methodology can be very, very important, very strategic in order to predict with some time in advance reductions of rainfall for Africa, especially for Western Africa, for the Sahel and the northern part of Africa. I believe that this can be very, very strategic for prediction of drought, but you need to be inside the methodology, of course. You need to be a little bit expert, and you need to have data. You need to have data, of course, because the highest amount of data you have, the more precise would be the prediction. As I've shown, I have 70 years of daily rainfall data, daily from January 1st, 1951 to December 1st, 2020. But this, of course, can be extended in time, can be a permanent monitoring system. As a matter of fact, I call this as an early alert monitoring systems for drought. So I believe, coming to your question, I believe this can be a very, very important tool for Africa, because in Italy, in southern Italy, the damage, the problem is economical. But in Africa, in some parts of Africa, it can be very costly in terms of lives, in terms of people who are migrating, political instability, and so on. We all know what is the problem with drought. 73 to 75 drought, I think to remember that maybe like 100,000 people died of famine. So it is. I think it is very. It could be very important for African countries.
Mr. Marco, thank you for the presentation. I want to ask if at the end of your research, you were able to subject all your analysis into a model equation for prediction of drought in parts of the world. Whether you have come up with an equation based on your research for drought prediction. Thank you.
No, actually, I didn't come up with an equation, but it's very easy. There is no need for an equation. You just need to be monitoring the ongoing of the Oceanic Niño Index. What I want to say, if you have a database, all you need to have is a database. You put inside this database, you put month by month or 3 months by 3 months, you put the Oceanic Niño Index value or the Standard Oscillation Index, the other one from Australian Bureau of Meteorology, but I prefer to use ONI, Oceanic Niño Index. All you have to do is to keep monitoring the evolution in time of these values. When the cumulated value is reaching the threshold of 7 or -7, for instance, for El Nino, when during the month, if January, February, March, and usually El Nino starts in April, May, okay, in June. If by the end of the year, if you have reached high level, that's why I needed to have a threshold. The threshold is the level that tells me that most likely I'm going to face a very strong El Nino event. That's all you need to know. There is no equation. There is no need for an equation. You just need to give, for instance, if I were the head of an irrigation agency, I would put one person in an office to monitor these values. And when the value is getting higher, a certain threshold, then you need to be careful, and you need to be very careful, because most likely you're going to have in the Pacific Ocean, you're going to have El Nino, and the stronger the El Nino event, the stronger will be La Nina event, and the stronger will be drought. So there is no real need for an equation. All I wanted to do, and that's why I needed to have statistical analysis of variance, I needed to have proof, and I had this proof, that data of rainfall that happen during El Nino are significantly different from the average, and are significantly different from data of rainfall occurring during La Nina, which is what has been witnessed.
Thank you so much, dear friend Marco, for this full explanation and clarification. Now, I would like to introduce the president of ANAFIDE to you and to the participant. We are pleased to have with us Mr. FERTAHI Aziz, who will take the floor.
Thank you.
Merci. Donc, je vous remercie, Mr. Haj.
Thank you so much, Mr. Haj, for this training meeting. So I would also would like to thank everyone who came from Africa to participate from different countries. So here I would like to have a reflection that I would like to address to Mr. Marco. Don't we feel contradictions? We are in a world of contradiction. We have 70% which is covered by water. We have important rainfall, and we don't have there is a risk of water stockage. Is it something linked to the decision makers? What is the solution? What will be the solution, the next future solution that would allow us to not to have water shortage? There is water, but if the existing water is not used for irrigation for other purposes, if you just have an idea that would lead us not to be living in a shortage of water. So here I would like to have your feedback to this. How can the decision makers face water shortage with the climatic change, with the problems of overexploitation of water tables? These are problems. These are problems that we are facing. So we have to have adequate questions, adequate solutions to this phenomenon.
Pardonnez-moi pour parler en anglais, mais c'est plus facile pour moi parce qu'on a besoin d'utiliser des mots
technical words. I would speak in English.
For your question, Mr. President, Mr. Chair, and thank you for your appreciation. Actually, I will tell you this. This is the first time. This is the first time I am presenting this data. Absolutely the first time, and it is the first time as well for my regional governments. So now I am in the phase of advising irrigation agencies, irrigation bodies to consider, to take into account this kind of approach. Because as of now, the problem is that when you have pressure from the farmers, the people who are leading irrigation agencies, who are governing the reservoir, they act under the pressure of the farmers. You know, they go there and they say, we need water, and what they say is that anyhow, we don't know if it's not going to rain. Give us some water and then it is going to rain. But in this case, this is a new approach. If you have statistical proof and you have reasonably doubts that it's not going to rain because you have had a very strong El Nino, then you have an instrument to answer to the farmers and say, look, even if you are making pressure, even if you are telling me you need water, I cannot give you water because I reasonably know that it's going to be drought. So even if I give you water, there is not going to be any more water. So I think this is in process. This is new even for Italy. So your problem is our problem. We have the same problems. So, I mean, I want to present this also to Italian, Southern Italy government and to Italian government. This is a very important decision-making tool. For the first time, I think, at least in Italy, for the first time, we have an instrument. We have a decision support tool that can help decision makers in providing justification for reduction of water. So your problem is our problem. So I will tell you how we are going on, because this is the first time actually.
Thank you very much, Dr. Marco. I think this is very important research work. And as we discussed it before, we have to continue. This is very important. This is an early warning, very simple. It could be very helpful for decision makers and also for irrigation directors and others.
Yes.
So sure, we will try to find more intensive data in other countries, and we can cooperate in such great research. So thank you very much. Really, it was very valuable research and information. Thank you.
Thank you. Thank you. Let me just say, very important is to have reliable set of data of rainfall. The longest, the better.
Sure, we will try to find it.
Well, thank you so much, Marco, again. It was a pleasure to have you in this training session. As you know, sponsored by ICID, by Chinese National Committee of Irrigation, and by the Afro-Asian Regional Development Organization, and ANAFIDE, of course. So I think we hope to see you, as you said, very soon. Fortunately, you could not join us, but we keep a very good impression and memory from this intervention. And I would like to free you because we took your time. I mean, you made an effort to be available all this morning. So I just send your greetings from our President, Mr. FERTAHI Aziz, and from our General Secretary Pandya, and from Mr. VARMA, from WAHBA, and all the participants. They are from a really large number of countries. Thank you again, and see you later.
Thank you very much. Thank you very much for inviting me. It was a pleasure and a honor. Thank you.
Okay, I guess we will move to the restaurant for lunch, and we will come back here for the closing. And okay.
Now there is a good news for the ICID sponsored candidates. Today you are going to get your podium. That's most important. And then we got some concerns from some of the participants who have come from different countries who are sponsored by ICID, that terminal allowance which we have given of $150 is not sufficient to take care of the COVID test. So what we have discussed, that you can prepare a statement showing what was, how much was the visa fee, how much is the travel insurance, how much is the COVID tests in your country you have paid, and then how much you are going to pay in Morocco. And for Morocco, you can take around $65 because we have inquired that conference is organizing a booth in the Kenji Rose Garden. You can get a test done there. It may cost around $65 with today's rate. You can include $65. And then you can prepare a statement. And then because $150 we had already paid, and balance we'll see how we can reimburse that also. So you can prepare that statement, give us that statement, and if you have a supporting documents like receipt, then you have to give that receipts also. If you don't have the receipt right now, then you have to send the receipt afterwards for our record, because for accounting purpose we require all the receipts. And then if you have WhatsApp messages, for the time being you can share the WhatsApp message with us. We'll record that WhatsApp message as a amount, because we don't know how much amount you have paid for different tests in different countries. So based on the conversion rate, we'll convert it into dollars. You can prepare that statement and then share with us. In the that's after lunch, we'll reimburse everything per diem, and then we'll see how the difference can be reimbursed. Okay, it's clear to everybody. So we break for lunch. We break for lunch. We break for lunch. We break for lunch. And after lunch, we'll assemble here again for closing ceremony. And then before or after their closing ceremony, we'll try to reimburse you your per diem. Thank you.
الو الو
You can take this chair. You take this chair. No, you just be seated. She'll take this. No, she will take this. You just be seated.
So we wait for the food. Should we are ready? Is the housing question. It's all matrix.
Anglais traduction, English translation, English interpreting services, English interpreting services, English interpreting services.
Would you like to talk first, Dr. Ragab, or you?
Yeah, I can start.
Dear participants, we are happy to have you all in this closing ceremony, and we are very happy to have all the management of ICID and ANAFIDE present here. Dr. Ragab, President of ICID, Dr. Pandya, General Secretary of ICID, Mr. VARMA, you know him, and Mr. Aziz FERTAHI, President of the Moroccan National Committee of ICID, and the Honorary President, Professor Felix Reinders, who joined us. We thank him. Now, to start, I guess I will give the floor to the General Secretary, Dr. Pandya.
Thank you, Dr. Batali, and Dr. Ragab, President of ICID, Dr. Felix, President Honorary of ICID, and then our African Regional Group Chair, and Dr. WAHBA, we is also Vice President Honorary, and Dr. Batali, the President of ANAFIDE, and other senior office bearers from the ICID. It's matter of great pleasure for all of us to be here and share with you the experiences that we had in doing this capacity development program. The capacity development program of ICID is unique, and we are working very sincerely to nurture the upcoming experts and upcoming approaches in the agricultural water management across the world through the young professionals, because you have a long way to go and you have a long impression to make in your respective countries. So it's a matter of very great pleasure for me to find that all of you have been able to benefit from the experts of ICID in nurturing your knowledge, in finding new approaches. And ICID is also grateful to the high patronage of His Majesty the King Mohamed VI for the unstinted support that we received from his government in organizing this program, as well as the future oncoming African Regional Conference and the International Executive Council meetings. With all these great difficulties of pandemic, had this support not been there, it would have been very, very difficult for us to really make a mark in this direction. So we are very much grateful for that. And at the end, I would request all of you that you should all be the ambassadors of ICID in carrying the message of efficient agriculture water management in your countries, and promote the thoughts and participation with the ICID community, especially the professionals in your countries, so that the entire field receives a global outlook and also receives a complete world picture about how the globe is maintaining and managing its agricultural and other water resources. So at the end, I thank you all for having come here, taken all this trouble in this difficult circumstances, made the travel, and then attended this conference. And I wish all of you great success in your endeavors in whatever areas that you are working, and wish that we will continue to work for future in this direction. Thank you very much.
Now I give the floor to the president of ICID, Dr. Ragab.
Thank you, the president of the 5th Regional African Conference. And I would like really to thank you all, especially the young professionals, for attending the 5th African National Conference. It is really one of the moral obligations of ICID towards young professionals, and we believe you are the future, and we need to equip you with the necessary knowledge to lead the future. This program, which was about capacity building, as the Secretary General, Dr. Pendia, mentioned, is really ongoing. It's not annual event, but it is ongoing. It is part of ICID infrastructure and long-term commitment towards young professional. A lot of people really behind the scene, they have been really helping you to achieve the outcome of this capacity building. And I would like to thank in particular the organizers, ANAFIDE, the Moroccan National ICID Committee. And I would like to thank the coordinators, Mr. Aziz FERTAHI, the president of ANAFIDE. And I would like also to thank, and I feel that you, all of us, are grateful to one person here in this hall, is Professor Dr. Al-Hussein Bertali, because we are all really grateful for him for looking after major and minor details to make this event to be successful. And I really salute him, and I really I feel myself personally grateful for all the efforts that he made behind the scene. He is also the vice president of the ANAFIDE. And I would like also to ask to thank Dr. Mohamed WAHBA, who is actually your coordinator as young professionals. And Dr. Mohamed WAHBA has been really instrumental in moving forward that young professional groups. And I feel that he has got now almost 52 WhatsApp groups. And whenever he sends one message, I get 52 messages in my mobile phone. But I feel he is really, whenever anything really we put forward to national committees, in 1 minute after it is sent to you. So basically that you are up to date as much as any national committee for what really we discuss and we decide in at the central office level. So I would like really to thank him for all his efforts and for being responsible for 52 groups from Africa. And of course, ICID office has been really facing unprecedented time because of COVID. And a lot of meetings were put on the shoulders of number of people in the central office, Dr. Pendia, Engineer Harish VARMA, Engineer Shivati, and also Engineer Madhu. This really group, I wouldn't have hoped for a better team to work with than this team. And they came into something completely new, how to run ICID virtually during that time where we cannot be physically with each other. So they had really a lot of work on their shoulders. They never really let ICID activities to fall behind. We were ahead of ourselves. And thanks to these 4 men, really ICID I'm also grateful on behalf of ICID to these 4 men who pushed actually ICID to be at the forefront. And we did by far more than what expected, given that difficult time that we cannot meet. And we had more meetings than usual. We had more webinars than usual. We had more workshops than usual. So we actually had a year more productive than even the physical years. So I would like to thank on your behalf this foreman of ICID. And the speakers actually are volunteers, and they volunteer their time, knowledge, and experience to all of us. And it is a commitment, and I said it's moral obligations from seniors to juniors, because you are the future and we need to equip you with the knowledge we have. And at universities that I learned one thing, any professor would say, if I cannot make my student better than me, it means I failed in my mission as a professor. And that's actually the attitude of those actually our seniors, ICID seniors, and they would like to be better than them. And that's really what we hope for. We hope for a better generation than our generation, and we will help you to be that group. So I would like really to thank all of them. Of course, President Honorary Felix, for the continuous support to young professionals. I have been with him for so many years, and he never missed a year without really offering his support and offering his lectures and experience to young professionals. So I would like really to thank Professor Felix for his support. There are also Vice President Marco ARCIERI, and he is also keen to transfer his knowledge and experience to all of you, and I'm sure that all of you will be also appreciative of his efforts that he makes year after year. Also, my thanks to Dr. Deng KUNLUN and also Mrs. Domelatel Valley, the FAO Cairo officer, and Mrs. Ihsani Al-Meknasi, Mr. Abdullah Al-Hari, and also Mr. Sufyan Sharafi, and Mr. Yassin Derfawi, and Dr. also Kamal Al-Labas. So all those lecturers and professors, they did their best to also to transfer the knowledge to you. And I would like really on your behalf also to thank them that for all the efforts that they made voluntarily and nothing else but to equip you really with the better knowledge and experience and to help you with your future. So on your behalf, I'd like also to thank them all. It was really quite extensive 3 days, and I'm sure that you enjoyed the 3 days lectures, but also there was one exciting field trip, and also that I hope that you have seen things in nature, how they work, and I'm sure you've benefited from that. And also I would like really to say something about the ICID in particular as an organization, never and not like any other organization. The ICID is a unique position, that the only organization that dedicates activities and capacity buildings for young professionals. I haven't seen any other international organization is doing this. And I would like, of course, to thank the sponsors. The organization, the sponsor, this activity in particular. And this year, of course, we have got sponsorship from the Moroccan National Committee and also with ICID. And I would like to special thanks to both sponsors from the ICID side and also from the Moroccan country side. And sincere also, sincere. Yeah. And also I would like to thank the Chinese National Committee and the South Korean National Committees for supporting ICID for for sponsoring this activity. And before really I close my final words, I would like to thank the Moroccan National Committee for the hospitality and for looking after us extremely well. And I have been myself personally working here in Morocco for 3 projects at least. So I know Morocco is like a second home country. I have a lot of friends here in this country, and I can tell you that it's really a country that's very welcoming, and also I feel that the hospitality that we have seen here, the welcoming and the warm really feelings, that really is something that I would expect from the Moroccan people here. So I would like really to thank all the Moroccans here, nationals, that they are with us for making our life easier and pleasant during that conference and training time. So on your behalf, I would like to thank all the National Committee members of Morocco. At the same time, really, I would like to wish you at the end a very successful future career. And I would like also to ask you to be always in touch. Don't lose the contact with ICID. And if there is a chance to talk to your officials in your country about the benefit that you as young professionals get from ICID, please let them know that we are welcoming your country to be a full member of ICID, and we are ready to accept, of course, and welcome any African country that not yet a member of ICID. So I would like really to wish you, if you are still staying with us until the conference, I wish you a very pleasant stay. If you are really going home, I wish you a very safe trip, and I wish that you benefited from this actually training session, and hopefully we'll see each other again in 1 year's time or perhaps earlier. And I wish you all the success in the world. And until next time, we'll see you again. Thank you very much.
Now I'd request Vice President Honorary Dr. WAHBA and Chair of African Regional Working Group to say a few words.
Thank you, Dr. Bandia. Good afternoon, everybody. Excellency, Dr. Ragab, President of ICID, Dr. Felix Render, President Honorary of ICID, Dr. Ashwan Bandia, Secretary General of ICID, Dr. Aziz FERTAHI, President of ANAFIDE, Professor Hussein Bartali, Vice President of ANAFIDE, and Engineer Mohamed, Secretary General of ANAFIDE. Distinguished participants, it's our great honor and pleasure for us to be here in our second home country, Morocco. And we thank the ANAFIDE for the kind invitation, and we are so grateful for the hospitality from day one to arrive. I would like also to thank each and everyone who has contributed and worked hard with us during the past couple of days and during the preparation for this important event. I would like to pay my deep respect to all the distinguished participants for your positive participation and valuable discussion in the training workshop. In fact, we have learned a lot and enjoyed all the valuable information given during the 5 days training sessions and field visit. I hope that what you have learned through the training workshop will help you a lot in your duties and lead to achieving sustainable development in the future of your own country. As we have heard over the past 3 or 4 days, there are great challenges around to meet our needs for future generation to come. In the past 5 days, we have learned about micro-irrigation system, planning of micro-irrigation system, calculation of water requirements, design of micro-irrigation, maintenance and the spare parts, water user association, water accounting, climate change and its impact on water resources. And of course, today we have learned about rainwater harvesting and predicting of drought and flood events. We enjoyed the field visit to one of the Moroccan drip irrigation project to cover about 4,000 hectares. It is a great project and we enjoyed it too much, and I think we need to learn more from this experience. I would like to inform you that the activities of the African Young Professional Forum during the year will include webinars, physical and virtual training. Also, we disseminated the training need assessment, and this is very, very important for our future activities. So I encourage all of you, and if you don't have it, I am ready to circulate to all of you. ICID has a huge network of expert scientists in all important topics of water, agriculture, drainage, environment, and sustainable development, and others. We are very ready for any tailor-made training upon request from any African countries or any national committee. I believe we have reached to an important stage for our great cooperation and partnership. And together with all our partners, we can and sure we will do more fruitful achievements. Allow me again to take this opportunity to express my appreciation and thank to all our great partners. And I will not repeat them again, but of course, our deep appreciation and thank is reaching all of them. In this regard, I would like to thank the Moroccan government, the ANAFIDE, the organizer committee of the training workshop and the 5th African Regional Conference. Of course, to Dr. Ragab, President of ICID, Secretary General Dr. Bandia, Dr. VARMA, Executive Director, and of course, we have to thank Dr. Aziz FERTAHI, the President of ANAFIDE, for his unlimited support for all the activities of ANAFIDE. And of course, we have to give a special thanks to Professor Bartali, Deputy Chairman of ANAFIDE, for his great efforts and hard works during the last 2 years. In fact, we have started early during the last 3 years, and we consider we organize this conference 2 or 3 times because due to the situation of COVID. I would like to encourage all of you to be active in all our activities, to try to disseminate all knowledge and information you have gathered at your national level, to do more your best to have your country active member. Until now, we have 8 African countries member and 7 countries associated members. Still, we have many African countries, and we will be with you until to reach to the majority of African countries to be a member. I wish to see all of you active member again, and of course, we wish to see all of you leaders, ministers, and of course to be member in all our working group. To see you Vice President and of course maybe President of ICID. We are looking forward to see you all face to face again in our activities. I wish you a fruitful participation in the 5th African Conference, and I thank you.
So now I will first invite President Honorary Felix to say a few words, and then we will be requesting all of you to provide your experiences in brief for our feedback, and then we'll conclude with Dr. FERTAHI's concluding valedictory address. So I now request President Honorary Felix to say a few words. Thank you, Secretary General.
Well, it is a real pleasure and an honor for me to be here part and parcel of this young professionals training. I had the opportunity to provide you with some information while I was in South Africa on the 19th on different aspects of irrigated agriculture. But this is now really a great privilege to see each one of you in person. And if I stand up and I look over the audience here from my left, and I just see smiling faces, and I see young professionals full of enthusiasm in terms of taking on the world out there in terms of the job that you need to do. And I know you're all excellent in what you are doing. And this training session, I think, complemented your already existing knowledge. So thank you to the Moroccan government, Aziz, also for your kind invitation for us to attend here, Professor Bartali, everyone that were involved in terms of putting this young professional training together. It is of high importance in terms of training the leaders of tomorrow. So I wish you all the best and congratulations to each one of you in terms of successfully completed this training session over the past couple of days. Thank you very much.
So now what we will do is to conserve the time, we will be inviting all of you to say your impressions, whoever would be interested in providing your impressions to us. And simultaneously, we will also carry out the certificate distribution. As far as your impressions are concerned, we'll put the mic in a roving mode, and you can provide your views from your seat. So yeah, we can call them one by one. And then who would go first in providing the impressions? Yeah, please. I think this one will work.
Oh no, we'll use it. Yeah, like this.
Yeah, please go ahead. You can use this.
Thank you very much. Good afternoon, everyone. I hope you had a pleasant lunch. And my name is Lukonga Ngalama. I'm from Zambia. I work with the Ministry of Agriculture under the Department of Agriculture. By profession, I'm an agriculture engineer, but currently working as an irrigation engineer in one of the districts in my country. Thank you. I'm very pleased to be part of this delegation for this workshop. Actually, it is something that is so overwhelming to learn when you are at home, when you're doing it the traditional way. You don't know what is happening in other countries. You might think what you're doing is the best, not until you move out and see what others are doing out there. So my coming to participate in this workshop, and actually the training that I've acquired throughout this workshop, has actually taught me a lot. There are so many gaps that we are having in our country. Of course, we have some irrigation projects, but not as big as what I have experienced in Morocco. And of course, there are things that we take for granted, the water, of course, and agriculture as a whole. When you are in a region where you receive rains almost throughout the year, you take it for granted that the resource is abundant. But what we all need to know is that water is a finite resource, which at the time when we think is abundant is the best time to conserve it, because we may need it for the future. And I'm very grateful for the organization of this workshop, to ANAFIDE, to ICID, because it gave me an opportunity to see how the state of Morocco is managing its water resources, how they are working in collaboration with the farmers to enhance irrigation, to improve food security, not only at household level, but also to improve the economy of the state of Morocco, which is very interesting and exciting. And I'm hoping that what I've learned here is going to help me in my work, my profession back home, to help contribute to policy, and also to help improve the mindset, because the mindset back home is something that we really have to work to. We may have very good projects, but if the mindset is not up to date, people are not convinced they need to improve, then it is very difficult to implement some of the projects. Of course, some projects have been implemented, but we've had issues where ownership comes in when the project comes to an end, an issue of transition. So that is actually one thing that I have learned. Farmers have taken agriculture very serious, and they've taken the need to conserve the water resource very serious. And I also had an opportunity to go to the museum, to see the water museum, to see how the water resource has been managed in the state of Morocco. And it is very amazing. I've really learned a lot. And actually, to share it with my supervisors, with my ministry, it will be very, very interesting, so that we can see how best we can come up with some policies that are going to help our country develop in that sphere. Thank you very much.
Yeah, please lift your hand. Please lift your hand if you. Yeah, please.
Assalamu alaikum. Good afternoon, everyone. Really, it's a great opportunity to participate in this workshop. And many thanks go to ICID for their interest in training young professionals. Actually, I have participated in earlier workshop at Egypt at Cairo Water Week with Dr. WAHBA. And I just would like to advise my colleague as a young professional that irrigation is the core of the development of countries. If we want our countries to move forward, we need to focus on irrigation and water management. After that, we can provide food for our countries. And by that, we can provide development by industry and technology. So irrigation technology and irrigation development is the base of development for each country. And this is what we need to focus on. Thank you.
Kindly introduce yourself. Did you?
Sorry. Dr. Ahmed Sheikh Hayati from Sudan, member of Sudan National Committee and assistant professor at University of Khartoum.
Thank you.
Yes, from Nigeria. From Nigeria.
The giant of Africa. My name is Engineer Murtala Muhammad. I work with Upper Benue River Basin Development Authority under the supervision of the Federal Ministry of Water Resources. Actually, this is my first time of attending this program. And I don't know where I will start, but the truth of the matter is what I have learned over the days have changed my perspective towards irrigation activities, especially with the Moroccan experience that has to do with the automation of water distribution to farmers, in the water budget, in the water accounting, and the technology or the technique they use in distributing water downstream on one platform to farmers and for domestic water supply. That is a very good technique. The Moroccan experience in terms of comparing or studying the climate change vis-a-vis the present situation of Morocco that has to do with maximizing what they have to improve the output of their agricultural produce is a good one to carry over to my country. Without saying much, the tradition in Morocco, the water museum, the spiritual aspect of it, the modernization aspect of it is just beautiful. How can I go into put it? The Moroccan people, or I can say the people in Marrakesh in particular, I don't have a word to thank them for the hospitality, the love, the caring. I hope we will come back next time for another program, And in particular, I will thank a friend that I met who become part of me as a sister. She always assists, she always assists, she always assists. Thank you very much. Thank you.
From Senegal.
Bonjour, je m'appelle Rahmatoulaye Naresidebe, je suis du gouvernement du Sénégal.
Hello, I'm Rahmatoulaye from the government of Senegal. I'm also working on FIDA project, technical support of FIDA projects in other countries. And I'm really pleased to be taking part in this training. As my colleague said, this is something we are used to do in our country, irrigation and valorization of irrigation techniques, adaptation to climate change. We always have projects on that, but today we have an added value through this training that allows us today to better conceptualize and design our irrigation system, to better talk and argue with our government on some politics, and also, highways, understanding highways, water, where it comes from, where it goes. That's the means of development, the path of development. As I said to Mr. Professor Bertelli, with our Minister of Agriculture yesterday, I will be the fervent defender, advocate of CIID to have a committee in Senegal that has not yet set up. We talked yesterday with the Minister of Agriculture about this. I hope we can also have other collaborations, because all speakers, all young professionals from other countries can have exchanges through the website and the field visits. That's what can allow each and every person to learn from the other country to press ahead. I think there are a lot of ideas that can come from here, like field visits to different countries, exchange with our producers and other producers from other countries. I hope all this can be done. Thank you. It was a real pleasure to be with you. Thank you.
From South Africa.
Afrique du Sud.
Good afternoon, colleagues. My name is Sidney Shkwambana from South Africa. I work in the Ministry of Agriculture, Land Reform and Rural Development under the section for water use and irrigation development. I was happy and honored to attend the training. One of the reasons why I was so excited to come and attend this training is because I'm heading the section for rainwater harvesting and micro, or together in combination with the irrigation system, where currently we are busy distributing the storage tank, 10,000 liters to 5,000 liters to the farmers, smallholder farmers, and we are giving them the package for family drip irrigation system. Currently, we are busy in the 4 provinces, but the aim is to do all the 9 provinces in the country. So coming here to attend or to learn more about the micro irrigation system to mitigate the climate change, it has helped me. And I think the experience that I have gained, I will go and share with the colleagues. Thank you.
Burkina Faso. Burkina Faso.
Bonjour, je suis Nadine Yaolire.
Hello, Nadine Yaolire from Burkina Faso, engineer from the Ministry of Water and Sanitation, and also member of the National Committee of Irrigation and Drainage from Burkina Faso. I think it has all been said, but let me start by thanking Dr. WAHBA, through whom I have been able to find out about the form of young engineers in irrigation, and I have been able to follow a lot of activities through different information formats they've had. We've had a lot of talk about training programs, and through this, Professor Bartali, that I'd like to thank on the way, he sent us an invitation to represent the National Committee, and that's how I got here. Regarding this training session, it was really a very good experience, very rich, that I will certainly share with my other colleagues who are still back home, especially through the form of young engineers that we try to rejuvenate. And through the workshops and webinars, we can together get ideas together so we can grow together. It was a special, good experience. We have got to know how other countries get organized with regard to irrigation. That will help us back home to see with our line managers how we can actually think about the strategies to pursue for better development. Thank you.
From Djibouti.
Djibouti.
Bonjour tout le monde.
Hello everybody. Ibrahim Moula, Djibouti. Engineer, rural engineer. Just would like to thank first and foremost Professor Bartali for the kind invite. I also would like to thank all the various stakeholders who have taken part in this organization, especially ANAFIDE and ICID. The training was very rich, interesting, theoretical and hands-on, through the field visit where we came to terms with what was presented to us on the first days. So we have managed to see how Moroccan experience has developed over time and with the good feedback. For that matter, we have been able to see how the whole drip system and the conversion to that system and other practices have been able to contribute towards water saving and water management. I hope all the work conducted in this regard to improve water saving will still be advanced. Once again, I'd like to thank all the
qui ont pu participer pour que cette
participants
puisse voir le jour.
and all the people who have actually made this training happen.
From Egypt?
Egypt.
Well, I guess it's all said, but just introduce myself. My name is Dr. Iman Ragab, a researcher from the National Water Research Center and a member of the National Committee in Egypt. Well, ICID never fails us in preparing and putting together the content of the young professionals training, and not only on the technical part, but also from the social part, as with its ongoing activities, it spread and widened the social networking between all the African countries and all the international members of the ICID. Then again, I want to thank ICID, and I want to thank Professor FERTAHI for his non-stop cooperation for all the members, and of course ANAFIDE for the continuous support to put this event in this very good place that we're in now. Thank you.
Tunisia.
Salut tout le monde. Je m'appelle Latifa.
Hello everybody, Latifa Dawati, researcher in the Oasis Agricultural Center in South Tunisia. First of all, I'd like to thank Mr. Bartali for the efforts to make this event happen and invite us to it, and also ANAFIDE for this good organization for a number of days of training. I would like to thank all the participants for the exchange we've had between us. These are our new friends, if I may say so. I would like also to thank the speakers during the training session, especially lecturers and speakers, because they've given us a lot in terms of approaches that can be so useful within our country and also within Africa, or even can be useful internationally if we exchange with other researchers and engineers. I'd like also to thank water, this resource that has been able to bring everybody together. This is a vital resource, and irrigation water. This is one of our priorities to ensure our food security and water security. Once again, thank you. That's it.
From Kenya.
Kenya, allez-y.
Good afternoon, everybody. I'm Joseph Kimani. I'm an agricultural engineer from Kenya, working in the Ministry of Agriculture under the Directorate of Agricultural Engineering Services. A lot have been said by my other young engineers before me. I would just also like to say thank you once again for the organizers for this opportunity. And we've learned a lot, even interacting with the other young engineers. At least now we've gotten new friends, and we can share ideas even when we go back to our country. So for me, it's a nice opportunity, and I want to say thank you once again. Maybe my colleague can say something.
Good afternoon, everyone. I'm Elizabeth Mwendwa, as well from Kenya. I'm grateful to Dr. WAHBA, first of all, for bringing us together in the various groups and always coordinating us. Also, much appreciation to the ANAFIDE and ICID as well. Personally, I've learned so much that I'll be able to make use of back in my country. And Yeah, I would say the presentations were very well tailored to the African context, which I found to be very useful. We look forward to continue partnering with ICID in future. Thank you.
Just for information, that the young professionals from Kenya have been jointly sponsored by ARDO. ARDO is Asia Africa Rural Development Organization, which is we have a MOU with them, and their headquarters is in Delhi. We have a MOU, so they have partly sponsored, and partly we have sponsored from ICID. So it is a joint sponsorship. Benin.
Merci beaucoup. Moi, c'est Héritier Tabara.
Héritier Tabara, hydraulic engineer from Mali, member of the National Committee of Irrigation and Drainage. Work with Taras Santari, Vice President of ICID, that I'd like to thank here. My sincere thanks go to Dr. WAHBA, who helped us experience everything through WhatsApp groups, and one of the new groups created, and that has allowed so many young Mali people get to know about ICID. I'd like to thank everybody, ANAFIDE, ICID, for the opportunity to participate in this rich training. And I would like to say that really we were surprised, and we very much appreciate the Moroccan experience in efficient irrigation. My colleague started speaking. You know, Mali, we have water resources that are abundant. We have a lot of streams, a lot of rivers there with a lot of sustainable water. So people don't understand this efficiency, but there are many areas in the country, in Mali, that suffer from this phenomena of climate change, and where rainfall agriculture is becoming uncertain. So we have appreciated this drip system and the efforts of Moroccan government to support farmers, private or communities, in this reconversion. I hope these notions will be taken up by our government and officials, so they can attach more importance to that. I'm in a firm study, I don't work. I'm in a study firm, I will not work for the government, but I'm glad to see the private sector contribute to this too. Thank you.
Other than Morocco, any of the countries left?
Est-ce qu'il y a un autre pays autre que le Maroc? Alors le Maroc dispose de beaucoup de participants. On va leur accorder 3 paroles en fait. Quelqu'un du Maroc qui voudrait prendre la parole de ce côté? Est-ce qu'il y a quelqu'un du Maroc?
I'm Abdullah from Nigeria.
Je suis Abdullah de Nigeria. Je suis Abdullah de Nigeria.
All the organizers, but I think it's very important at this point we specifically mentioned the translators of this this workshop. We need.
Merci. Donc,
thank you. You're so kind. Nice of you. I'm Raja Tanji from the Ministry of Agriculture, Directorate of Irrigation, Rabat, and I've had great pleasure to be with you during these 4 or 5 days of training. So it was very enriching to exchange and interact with all the participants, with the program that was rich in information, practical, hands-on, in the field, and also with the speakers on different important aspects, especially water accounting, spot irrigation, drip irrigation. What we saw also this morning about rainfall collection. And here, by the way, I'd like to thank CIID, ICID for participating and for organizing this session for young water professionals. I'd like also to thank Dr. WAHBA for all the work he's done in Africa. And I'd like also to thank my professor, Dr. Bartali, who is always with us to support us in organization before, during the training. So thank you all. I'd like also to thank all the participants from other countries. And we should stay in touch for the future, even online. Thank you.
I'd like to thank all the people present here today. I have had the pleasure of making your acquaintance. Yes. So I'm sorry. So I am Darfawi Yassin, and I am head of the Center for Management and Remote Control of the Ragab Canal, working for the Regional Office of Development of Agriculture in Marrakesh for the region of House. I'd like to thank all of you present here and the ICID as well as ANAFIDE for having granted us this opportunity. I think as I have been both part of the youth training and one of the people present for your field visit, I am very happy to have met all of you because our experience, as good as it may look for you, it is still a humble experience and it needs a lot of fine-tuning. Through your input and your thoughts, of course, we have got a lot of information throughout this session from the doctors present right here and those who have not been able to be present today. As we have taken a lot of information related to collective conversion to drip irrigation and the individual techniques related to rainwater. We have been blessed to have had this opportunity. And I'd like to reiterate my interest in every single experience in every single country, because as Morocco has a lot of diversity in relation to its agricultural culture and use, we have different and very wide range of agricultural techniques, and they have been inspired from our own experience, but they can always be developed and improved even more through your input and your thoughts. So I have been really honored to have met all of you. And as the COVID pandemic has taught us, we will always be able to keep in contact with each other in the future. And I hope that we will do that and not let this fire that we have in us right now go down and wither away. So I'd like for this motivation to fuel every one of our hearts, and we try our best to improve our countries. And one thing that I would like for you to know is that this kind of event is really nice even for us who have participated from Morocco. Afaf, Atman and I are part of the regional office, but we have had the ability, thanks to this event, to meet people from our own country in other regional offices, and being able to share experiences with them and having had the opportunity to meet them, we're even more thankful for that. So thank you very much.
I missed from friend from Ethiopia.
Okay, thank you. My name is Kadrala. Actually, I didn't come directly from Ethiopia. I'm a student here in Rabat, AV. In the last 3 or 4 days, I have gained a lot of information, a lot of knowledge from different presentations. Most or major of the presentations will be part of my data collection in my PhD research in the future. Actually, I have some plans. I will collect the data from here in Morocco and from Ethiopia. So it was a very good. It was very good opportunity for me, in which part I will give focus for the future in my research. So actually ask to maybe if it is possible, we need or we want to the presentations, the slides for the future for our research purpose. So thanks a lot. We will contact in the future for actually I will contact every one of you if I get the chance to contact to gain for the future my research purpose. Thanks a lot.
I have kept in the last because he is representing both Ethiopia and Morocco. We have a colleague from African Union. So he has attended. Who? Oh, no.
Thank you very much. Excellencies, distinguished participants, thank you very much for inviting the EU Commission. My name is Mure Agunlaho. I'm an African. Though I was born in a country in the continent. One thing I've learned since coming here concerning ICID is I noticed that this is a distinguished and very organized organization. I've had contact with Felix. I'm sure you will not. I've sent you email not once, and I've also had contact with Professor Bartley. The first time I actually got in touch with ICID, we wanted to validate a framework we had at the continent. And I sent a mail. I was just doing a web search and I saw ICID. That was the first time. I think that was about 3 years ago. And I sent a mail to Felix and also to Bartley. Felix gave an excuse that he was traveling to Asia or something like that, either to India. But Bartley was with us in Addis and we had the validation. That was the first time I had contact with ICID. And since then, I will say this, that this is an organized organization, distinguished elders, and I'm very glad that you have this plan of inculcating into the youth what you have learned. And the training program is at the heart of the AU Commission. We're organizing something like this at the AU Commission, but I would say that it is far from this. It has been an honor to be here, and I thank you all on behalf of the participants. This is actually what we want in the continent. We don't want our youth to go down to Europe through the hard way. We want them to stay in the continent and develop their various countries. So it's a pleasure being here. I thank you all for this opportunity, and I will convey the message back to the AU Commission. I greet you.
Thank you. What I suggest that AU Commission and ICID can have an MOU so that we can cooperate in future for all in our areas of work, mutual interest. Yeah. So our friend from Lithuania.
Thank you. So my name is Otilia Misatskaitė. I'm from Lithuania, from Europe, and I'm really very pleased to be here. I'm a researcher and lecturing in Vytautas Magnus University, Agriculture Faculty, Water Resources Management Department. And actually, it was so much told already. So I just want to agree with everything and thank for all of you for this time. And of course, to Mr. FERTAHI, special thank. And I'm really pleased to be here. And I just looking at you and thinking what Africa have a future. Because so many young professors knows how important water is, and we from Europe can also learn something from you, how to appreciate water and count each drop of water, because water is everything. So it's really, we have a future. So thank you very much.
Actually, she is not part of YP training. Let me make it clear. she has joined our training. She was here throughout, but she has come for attending conference and as well as see how we are conducting the training. Mr. Pandya, now you can take over. Now you can take over, means you can conduct. Mr. FERTAHI.
So now I'll invite Dr. FERTAHI to give his valedictory remarks, and then we will also have the certificate distribution. So first, Dr. FERTAHI.
Merci. Donc, en ce qui me concerne, au niveau de cette formation, à présenter mes vifs remerciements à Sa Majesté le Roi, qui a bien voulu honorer à ce que la conférence régionale africaine soit sous son patronage. Et d'ailleurs, en marge de cette conférence, on a fait cette formation et il a eu le soutien du pouvoir public marocain. Donc, il y a une grande contribution du pouvoir public en ce qui concerne la réussite de ces événements qui sont en marge de cette conférence régionale. De mon côté, depuis que j'étais élu en 2016 en tant que président de l'ANAFIDE, comme vous savez, l'ANAFIDE, c'est un travail de bénévolat. C'est un travail de bénévolat et donc je profite de l'occasion d'appeler nos confrères marocains qui sont ici à la salle de rejoindre l'ANAFIDE et de payer leurs cotisations et d'aller, c'est-à-dire de renforcer le travail au niveau de l'ANAFIDE. Donc, depuis que j'étais élu, j'ai opté, j'avais une vision de renouer avec la CID en régularisant tous les arriérés de la CID et de nouer de bonnes relations avec la CID. D'ailleurs, ça se traduit avec ce qui se passe actuellement au Maroc. À cette occasion, je voudrais remercier Monsieur Ragab, Monsieur VARMA, Monsieur Félix, Monsieur Pandya et Monsieur WAHBA de la CID et tout le staff de la CID qui ont contribué à cette formation. En ce qui concerne également, je voudrais remercier le comité chinois qui a appuyé cette formation de jeunes entrepreneurs et jeunes professionnels dans l'irrigation et dans le domaine de l'eau. En ce qui me concerne, je voudrais juste attirer votre attention au niveau d'un point très important. J'ai une remarque, c'est que je crois que toute l'assistance, c'est-à-dire la vision du privé, un pays ne peut pas se développer s'il n'y a pas un privé en parallèle que se développe. On ne peut pas se développer uniquement par les moyens de l'administration. Donc, la formation dans le domaine de l'irrigation et de l'eau est très importante. Et pour se développer, il faut qu'il y ait un privé qui se développe en parallèle. Il faut que les jeunes entrepreneurs aussi aient la réflexion d'investir dans le privé et de créer leur propre emploi, leur propre entreprise. Parfois, il y a des soutiens de l'État en matière d'entrepreneuriat, mais parfois il y a des échecs. Il y a un échec matériel, financier, mais pour moi, c'est un échec. L'échec social est beaucoup plus dramatique que l'échec financier. Quand vous avez des jeunes entrepreneurs en échec, ça veut dire que la société ne se développe pas, ça veut dire qu'il n'y aura pas un très bon développement du pays. Pour nous, en ce qui nous concerne au Maroc, je voudrais juste mettre en évidence deux dates importantes dans l'histoire du Maroc. C'est 1967, au feu Sa Majesté Hassan II a lancé la politique des barrages et 1 million d'hectares irrigués. D'ailleurs, c'est pour ça que le Maroc a actuellement presque une autosuffisance alimentaire. Et 99, avec l'intronisation de Sa Majesté Mohamed VI, qui a permis de moderniser ces infrastructures hydrauliques et qu'il a bien développé et qui ont abouti à des résultats qui sont très satisfaisants. Durant les dernières 20 années, nous avons construit à peu près une quarantaine de barrages au Maroc et nous avons des barrages qui sont en cours. Mais ces problèmes de réchauffement climatique posent problème parce qu'il y a un paramètre que je ne sais pas si vous l'avez cité, la formation ou pas, c'est que l'envasement des barrages. L'envasement des barrages est un problème très crucial parce qu'il peut vous faire perdre de 10 à 30% de la capacité de stockage. Et sur des budgets qui sont très élevés, c'est beaucoup d'argent, c'est beaucoup de milliers de dirhams ou d'euros ou de dollars, je ne sais pas, en fonction des différents pays qui vont assister. Donc, à mon sens, moi, je vous félicite pour la CID pour cette formation et je remercie tous les gens qui ont assisté. Et je vous invite tout le monde à assister demain à la séance d'ouverture de la 50e conférence régionale africaine. Et j'espère qu'on va, au niveau de la CID, prochainement savoir le pays organisateur de la 6e conférence. À cette occasion, je remercie également le comité marocain, en l'occurrence Dr Bartali, Bouham, et M. Belmoussa et M. Ahmed qui ont contribué à la réalisation de cette formation. Dr Bourarache aussi présent avec nous. L'ANAFIDE est ouverte à tous les différents comités internationaux. D'ailleurs, nous avons Madame Otijad qui vient de la Lituanie, même si c'est le nord de l'Europe, il y a beaucoup d'eau, mais il y a dans les années à venir, ça reste qu'il y a des pénuries d'eau même en Europe. Et en ce qui me concerne, encore une fois, je remercie la CID, Dr Ragab et Dr WAHBA et tout le monde pour cette formation. Je vous remercie.
So now we start the certificate distribution, and we will have it being handed over by jointly by Professor Dr. Ragab and Mr. FERTAHI. So we'll announce the name, and Sid Bey, Rahmatullah Nare, Senegal.
They can come here. Yeah, they come here. They can come here.
Very beautiful. From here. Yeah.
Yaulire Nadine Sugri Numa, Burkina Faso. From Benin, Maforikan Ella Sede.
From Benin.
Benin. Mabruki Jamal from Morocco. Misrar Wafa, Morocco. Lukonga Nkalma, Zambia. Otelija Misekete, Lithuania. Mohamed Zahi, Morocco. Dawadi Latifa, Tunisia. Marzouk Zakaria, Morocco. Sydney Sikawamba, South Africa. Kwarul Ilyasi, Morocco. Not here. Ramdi Ayub, Morocco. Abdullahi Abdul Rahman, Nigeria. Tanji Raja, Morocco. ये मोरक्को का है तंजी राजा या Aklil Hassan, Morocco. Hussein Kedrala Wabela, Ethiopia. Wandu Joseph Kimani, Kenya. Jabal Mohamed, Morocco. Is not here. Jabal Mohammed is not here. Boshalaf, Lubna, Morocco. Wendwa Elizabeth, Kenya. Zakari Usman J, Nigeria. Zakari. Isadi Adil, Morocco. Amharuk Othmane, Morocco. Nofal Iman, Egypt. Masoudi Fatma, Tunisia. Rutabara Hartier, Mali. Yeah. Safia Aliu Mahmoud, Nigeria. Maguri Lamie, Morocco. Murtala Mohamed, Nigeria. El Akruch Ahmed, Morocco. Mola Farada Ibrahim, Djibouti. Sose Alawi Muhammad, Morocco. Tai Mai Ali, Morocco. Bodgart Fatima Zahra, Morocco. Erwosibe Ademi Muima, Nigeria. Darfui Yassin, Morocco. Elfansi Salwa, Morocco. Ahmad El Sheikh, Sudan. Belabir Afaf, Morocco. Ngalma Lukonga, Zambia. Zambia. Lawal Abdul Rahman, Nigeria. We have 3 candidates left if they are there. Otherwise, we will give it to Dr. Bartali. He will take on. Yeah.
We request all the participants to hand over feedback form to Mr. Chipte before leaving. And those YPs who are sponsored by ICID, they should stay back so that we can settle their dues. And we'll request in the end for Dr. Bartali to say something. You're not visible?
Please, I would like to inform you that it is the first time to organize the first African Young Professional Workshop. It will be on Friday, 26th, but the schedule will be postponed maybe after the plenary session of ICID. All the workshop, it will be organized and chaired and co-chaired by the young professional. It is the first time and it is a good start. We are looking forward to have more workshop and conference only for young professionals. This is the first. The second, also, it is our honor to have some of you as a rapporteur during the session. So please, you can check the final program, which will be circulated to you. And I wish you a very fruitful contribution and discussion. And thank you very much.
So for tomorrow, we have in the morning session our colleague from la direction de l'irrigation. Microphone. Okay. And we have Al-Siddiq, Dr. Al-Siddiq. Al-Siddiq, please you and you, Ragab. You will be reporter for the first session, which will be chaired by Dr. Ragab on the strategies to cope with water scarcity. And this is the first session. The second session will be chaired by Dr. Felix after, and we will have two reporters, Elizabeth. Wenda, yes, and the second one.
We can.
Okay, so we'll give you the name. Thank you. Okay. Yeah.
We'll have a coffee break.
Thank you, everybody, for this wonderful training, wonderful cooperation from your side. Look forward to your cooperation in future and continuous interaction with each other and with ICID. And those countries who are not member of ICID, we request young professionals to, when they go back to their country, to convince their authorities to become member of ICID.